Hi, my name is Paco, and I'm grateful to get to present here today. Title is Thinking Sparse and Dense. Now, all the slides here, they're online. Frankly, there's a lot of links in them, so if there are parts that seem interesting, you want to chase down some primary sources or tutorials, hopefully there's a lot of good resources for you there. Just briefly about me, I made a mistake of studying AI in grad school about 40 years ago. Then I went off and spent years working in an area called neural networks, including hardware accelerators. And then I was a guinea pig for something new called AWS. And I've also been involved in some open source projects. These days, I do a lot of work with machine learning, knowledge graph, and natural language in open source. So this talk is about a recent report, just came out last month, on Manning. Dean Wampler and I wrote this. It's called Hardware is Greater Than Software is Greater Than Process. And there's a free download if you follow this link here. We did this working with some of the software leads for open source projects at NVIDIA, and also experts in terms of leveraging GPUs, various areas of machine learning and graph analytics, etc. So the gist is that really from a software perspective, as a developer, how can you make the most out of the hardware that's available? That's the gist here. And you need to develop intuition about how hardware works and how to leverage that to optimize applications. You don't have to be expert, but understanding some of the fundamentals can really take you a long way, and maybe even knock down orders of magnitude increase in performance to enable things that you just didn't even think were possible before. That can open up entirely new areas of applications. And meanwhile, given what we're showing here, it doesn't imply a lot of changes for the data scientists and data engineers. Really, it's more about changing the process that's used, and particularly like continuous integration. From an engineering perspective, how can you set up better CI so that the data workflows in general work better? So, yeah, this is about a post-Moore's law world. What are the implications on data science and data engineering? And the report really goes into a lot more detail. The talk is just tip of the iceberg. But the thing that we noticed was that for the past 20 years or so, since publication of the Agile Manifesto, there's been this idea that process is something that's very general. It's like an umbrella. It applies to all kinds of different projects. Software is, abstraction layers. It's also very general. It's largely agnostic about the hardware. And then hardware is something that's a very low level. And those are resources that just keep getting better, faster, cheaper, thanks to Moore's law. Except that all three of those points are wrong. Hardware's been evolving more rapidly than software. Software's been evolving more rapidly than process. And we need to understand how to adapt to that, how to update the parts that are lagging. So I do want to cover a brief history, and really this is just super overview, but there's some good links to primary sources here. And the idea is that going back for the past 25 years or so, about every 5 years, there's this bump in technology that has a lot of ramifications for the software engineering side of AI applications. And so, if you roll back to like Q3 of 1997, there were 4 teams working independently on horizontal scale out. Greg Lendon at Amazon, Randy Shoup at eBay, on. And they came up with, scale out mostly on Linux boxes. But it established this kind of, it really set the stage for big data and cloud computing. But it established this thing that Andrew Ng calls a virtuous cycle of big data leading into machine learning. And then in 2001, Leo Brayman published the infamous Two Cultures paper that, heralded machine learning in production. But at the same time, the Agile Manifesto was getting published. And frankly, those two groups couldn't be more disjoint. They were like aliens to each other. And then 2006, I was fortunate to be a guinea pig for the launch of something new called AWS. At the same time, roughly, Intel was producing the first commodity multi-core chips. NumPy was released. People started talking about this thing called MapReduce, on and on. And then you roll the clock out to 2012, AlexNet, the paper was published that really opened up deep learning. And then in 2017, you had embedded language models were first released, learned indexes paper, and just in general, software 2.0. So you see like machine learning making major incursions on what had been software engineering territory. A lot of implications of that. But at the same time, you also saw Intel, after decades, falter on execution of 10 nanometer features. So here's a good visual of what happened over decades. There was exponential increase, Moore's Law, and then around 2005, it starts to flatten out. But at the same time, the cost of creating a fab to make chips was increasing exponentially. And in fact, it's up to like $15 billion to make a new fab these days. And at the same time, machine learning resources, the consumption of resources was outpacing the advances in hardware. So there should be red flags going off all across the board. Also through this arc, you have to understand the cultural aspects of this. If you read the Agile Manifesto, notice that the word data doesn't get used even once. That's crazy. Okay, there's been generations of software developers who've been taught about, fast iteration on the code base. Okay, coding is preeminent, data is secondary. But in contrast, there's a different worldview where learning is preeminent and data is a competitive differentiator. And those two things don't reconcile. Okay? The latter gained first mover advantage in terms of AI adoption. And Ben Lorica and I have been writing some reports. Others have come out from MIT Sloan and McKinsey Global Institute, et cetera. But really, since about 2017, we're tracking how there's this Peloton effect, that the firms that are investing in AI are investing even more aggressively. And meanwhile, more than half of the Global 2000 is years away from even getting started. So the projections are that by mid-decade, we'll see a rather large acquisition event where the laggards just basically become acquisition targets. So to understand this, hardware is evolving rapidly. And the best resource I will assign, go out and study. It's called the Geopolichips series. It's part of the Next Billion Seconds podcast by my friend Mark Pesce. And really, really brilliant reporting here. Great history, a lot of links. It'll set the stage for what's going on here. One of the proof points definitely is in terms of Cerebras. And so, they've come out with, they broke world records as far as wafer scale. And regardless of where this chip goes and gets used, I'm sure they'll become quite wealthy just based off the patents on wafer scale. But, really amazing, 1.2 trillion transistors on a single chip. And you see them holding chips. I got to hold one of those chips. In general, NVIDIA, shocked the world by buying ARM. And so now NVIDIA has three major families of hardware. They've, of course, got the GPUs they've been doing, but now with ARM, they have x86 processors. And they also have this sort of data center on a chip kind of processor. The idea being you can combine the three and produce basically boards that, are equivalent to what we would have called supercomputers. Really fantastic work because they're looking at this evolution of hardware and software together. What happens when your application is too big or too complex to run on your laptop or on a single server? And you got a couple choices. You can scale up, which means you get a bigger server, you buy bigger licenses. Or you can do scale out, which means you do some trade-offs and distribute the data and the compute across multiple servers. So the history of things like MPI and Hadoop and Spark and now Dask, these are generations of scale out. And they do imply trade-offs in terms of overhead costs, always, and risks, always. If you want to see some examples of distributed design patterns in Python, check out my tutorial there. The 1990s, MPI, that was spaghetti code. I mean, it got the job done, but it was spaghetti code. In the 2000s, in the aughts, you saw Hadoop and Spark and all, and the idea was to leverage commodity clusters, but you had these kind of synchronization barriers. You had a map phase, reduce phase, et cetera. And that led to, problems with asymmetries in data where you could have like really low cluster utilization while the stragglers finished. And then you get into 2012 and beyond that, you start to see the deep learning kind of workloads where really it required new hardware. It required point-to-point communications were quite different in terms of the I/O fabric. And so you see new things like, TensorFlow and Ray and all these addressing that. There's a great talk on these lines by Jeff Dean, 2013 at the Bay Area ACM meetup, going in detail about how they have these workloads. They have a new generations of hardware, particularly the I/O in their data center is new, and they're addressing these problems they have with really large-scale neural networks, training them and using them. And it isn't about the compute; it's about latency. It's about the bandwidth. If you read between the lines, Jeff Dean is really talking about what would become known as TensorFlow. But there's even more recent work on this that I think Evan Oldridge, who's leading the Merlin project at NVIDIA, has sort of picked up the ball and is running with it. So let's break it down in terms of concepts. And first off, I'll put up this straw man for like a general pattern for data workflows. In data science in general, there are two things we're really looking at. One is we're going from unstructured data to refining into more and more structure. And then along with that, we're managing and leveraging dimensionality. Those are the two big things we manage in data science. And the typical workflows will have, your data prep, your feature engineering, training, evaluation, deployment. And we can just, like I say, use this as a straw man. So I want to introduce this idea of thinking sparse and dense. So there are trade-offs in different stages of workflows, and they're really crucial for being able to leverage the hardware appropriately. Sparse kinds of work, these are typically in the early stages where you're doing data prep and joins. Typically, these are bandwidth limited. And, this work might be done off in CPU land, or if we're talking about deep learning, you struggle with this when you're doing your loss function calculations. But the sparse side is the symbolic side. This is what the stakeholders and the customers understand. So whenever we're talking with customers, we're often sparse land. The dense side of this, though, is typically your compute limited parts. If we're talking about deep learning, those would be your convolution layers, for example. These are the parts that are readily vectorized, so like in the training stages of a pipeline. And it's important to understand the distinctions between these and use them appropriately. There's a lot of math to guide this. So for instance, we can apply algebraic graph theory and abstract algebra to do transformations and inverse transformations between a general data object, which is one form of graph or another, versus an algebraic object, which might be a vector or a matrix or a tensor. Or there's this approach called non-negative matrix factorization. And the idea is you can project graph relations into a matrix and then do factorization decomposition techniques. I will point to Tim Davis at Texas A&M, sort of the grandfather of this area. Most of the production libraries that are used for number crunching in terms of factorization, he's had a hand in writing them. And then there's also David Gleick at Purdue, formerly at Stanford, really brilliant work in terms of deconstructing PageRank and other types of algorithms for this. So just as a real quick illo, working with PageRank, you come from different sources, you parse them, you've indexed them, you go and run the graph algorithm to rank, and then you work with inverted index to produce some sort of results. So you're going from sparse to dense to sparse. Okay, that's an example of what we're talking about. Tim Davis did a paper a couple years ago, and this is taking a look, of course, Neo4j is really popular as a graph database. But this is taking a look at something called Redis graph, which I really like. And on the same hardware, same data, same algorithm, Redis graph runs approximately 2 orders of magnitude faster than Neo4j. And it's because Redis graph is using something called graph blast. They're doing the dense thinking and the transformations from sparse to dense and back. They're doing that right. Neo4j, not so much. So dense is important. However, sometimes we have to blend the symbolic and the numeric. When we're working with graph algorithms, when we're working with deep learning, that's typically requiring numeric representation. But other times we have to work in the symbolic, the sparse side. So if you're doing compliance audits, if you're doing rules based on domain expertise, explainable AI, any kind of work in human in the loop or natural language, this is where the symbolic side, the sparse side comes in. There is a term emerging called neurosymbolic AI, and I've linked to an excellent paper by Neil Thompson at MIT. Also keep in mind techniques such as active learning and self-supervised learning, which really play into this. There's a project, I'm one of the committers on a project called KG Lab. We explore these ideas in more detail. So a general pattern for data workflows, here's our 4 steps of going from sparse to dense, crunch, back to sparse. And yeah, this is really a lot of the thesis of the report. Now, let's talk about languages. Python has become a lingua franca for working with data analytics, largely because of C++ under the hood. The history, going back to 2006, 2007, they were doing work with medical imaging, a lot of number crunching, and historically a lot of work close to the hardware. But yet at the same time, the language provides easy to use features. It's very concise. Alan Downey points out that in analysis of many papers, often the Python implementation of an algorithm is actually more compact than the pseudocode that was published in the paper. The Python language is very forgiving, but it allows a lot of deep access to the hardware. However, at the same time, Java happened, and that pushed people even further away from hardware. So our point is that better programmers write idiomatic code that hardware can optimize, with all apologies to Martin Fowler. Even so, there's a disconnect. Programming languages are really good at representing floats and lists and strings and all that. They aren't so good at defining formally where is it in the code that you need to focus on sparse, symbolic work on distributed software, scale out, versus where in the code do you need to focus on vectorizing, dense numerical work, probably running on a hardware accelerator. Okay, that's missing. That is a software engineering problem. It must be done at the workflow level. It's the work we have ahead. For this, you can kind of think of Python as like a really good DSL for C++. So, how to do this? Well, right now, one thing to note is that there are 4 key abstractions that just are missing in the high-level languages, but we use them over and over. So the report goes into much more detail, but definitely data frames, graphs, pipelines, and tensors. We need to have better support. Until we have better support in high-level languages, you need to understand how to work with these kinds of design patterns and how to use them idiomatically, because that's really the only way that the hardware can have any hope of optimizing for what's going on in the data workflows. I highly recommend use design patterns. Calm Code, Vincent Warmerdam will be speaking here. Outstanding work. And just in general, Stack Overflow has a lot of great content for this. Use comprehensions, use type annotations, but more importantly, use pre-commit hooks to really encourage all of the above across teams. That's part of your CI. And that allows, the low-level stuff, Arrow and CuPy and Numba and Cython and all that to do the heavy lifting. Use idiomatic programming. Also, learn how to use the profiling tools and learn about using profiling in depth with an iterative process. Start with a coarse grain analysis in Python, look at your call stack, look at your memory objects, and then drill down as you start to identify bottlenecks. You can drill down, there's great tools all the way down to hardware timelines. Iterate with this notion of like inspect, visualize, analyze, take action. And there's some excellent tutorials here. Here's a selection of profiling tools that I like in Python, particularly ObjGraph, SnakeViz, PyInstrument, and I've got a tutorial if you want to check out some examples of using these. The other thing is that as you're making trade-offs and doing the software engineering work, you need to understand how to measure. What we've seen is that time to market has become one of the most important metrics in terms of success or failure for AI projects. But yet at the same time, working on data science teams, you see, people spend so much of their time waiting for ETL jobs to complete, for models to train, for visualizations to render. With appropriate use of the hardware, you can cut out those wait states. And that leads to more success at the project level. So here's our 5-step program that's described in more detail in the report. And just to summarize, also, a few things keep me up at night. Really, co-evolution of hardware and software is becoming super crucial. And I will reference back to Evan Aldridge. Also, world powers are having conflict over chip supply chain bottlenecks and related cyber attacks. And I'm hopeful that doesn't go further. Also, we're going to need much better work on schedulers. And to that point, it's interesting. The south polar craters on the moon are the coldest points of the solar system, some of the coldest points. Also, they have perpetual sunlight. So, this would be a really good place to drop large clusters of quantum devices. And it's a great approach to mitigate climate change, that we just move our cloud computing off to the moon with renewable resources. Is there any organization that can handle both cloud computing and commercial space travel? I don't know.
Hello everyone, my name is Felienne Hermans and I'm the author of the Manning book, The Programmer's Brain. And in today's session, we're going to look at one chapter of my book concerning a technique I call cognitive refactoring. I'm on Twitter as well, by the way, so if you want to tweet about this session, my Twitter handle is @Felienne. In order to understand how I came to research cognitive refactoring, we have to go back into my personal history a bit. We have to go back to the year 2013 when I started to teach programming to children. And I didn't have a background in education. I had a background in programming. I just finished my PhD in software engineering. So I was really excited to teach these kids programming, but I didn't really know that much about teaching, which I thought at the time wasn't really an issue. I was like, well, I know programming and these are 10-year-olds, so how hard can it be? Well, it turns out it can be actually kind of hard because I didn't know anything about learning and these kids were struggling. They were confused by syntax. They didn't really know how to grasp new concepts and I didn't know how to help them. And because I didn't really know that much about teaching, I didn't know how to help them specifically. But it made me really interested in how people learn because these kids voluntarily came to the community center on their free Saturdays and yet they were frustrated and yet they were learning. So I was like, this is on me. I need to get better at knowing how to teach, knowing how people learn. And then ultimately this became my book because I started to learn so much about how people learn that I thought other people might benefit from what I learned as well. So I started to dive into cognitive science, the science of how people learn. And there's a bunch of things I took away from my explorations that I want to share with you today in this session, as well as in the book. So what actually happens in your brain if you read code? Let's look at what happens in your brain when you process information in general. So this is not about code specifically, it's about how we process anything. If information comes into your brain through your senses, your eyes or your ears, firstly, this information is stored in the short-term memory, which is a little bit like an I/O buffer. It's kind of small and it stores your information only briefly. Research into the short-term memory is very old, actually. We've already known since the 1950s, since the work of George Miller, that the short-term memory is very, very, very small. And we mean actually really small. So the human short-term memory can only hold between 5 and 9 elements at the same time. So that is very tiny. And just to give you a sense for how tiny this actually is, we're going to do a little memory experiment. So I'll show you a sentence very briefly, just like half a second. And it's your goal to remember this sentence, just so you can explore how little fits in your short-term memory. Here we go. Be ready? So that was like really hard, right? The information couldn't even trickle in your brain, in your short-term memory, and then already the time was up. And maybe you guessed that I was tricking you a little bit somehow, right? Because this was a sentence, yes, but it was sort of a weird sentence. I only talked about half of the picture so far. So let's zoom into what happens in your brain a little bit more. So once information is in your short-term memory, it is then further processed by something that we call the working memory, that you can see a bit as a processor in a computer that isn't just remembering like the short-term memory, but processing the information as well. Your working memory works together with your long-term memory. So your long-term memory is like an angel on your shoulder that says, hey, working memory, if you're thinking about this, here's some information that might be relevant for you. It's a little bit like Amazon recommends, hey, if you bought this book, maybe you also like this book. Hey, if you like this information that you're thinking about, maybe you would like this information as well. So your long-term memory very, very much supports your working memory in processing new information that you see. And just to experience that also, we'll do 2 more memory exercises with new sentences so you can see just how much your long-term memory helps you to process information. So here's another sentence. That was probably easier, right? It was still hard, but at least you could make some sense of what was happening there. You saw the letter maybe A and B and M. This was your long-term memory. Your long-term memory was saying, hey, these are letters. I know these letters. What do you want to know about these letters? And we'll do 1 more exercise, just so you can see that it is actually possible to remember such a short sentence in a very, very brief period of time. So are you ready for the next sentence? Here it comes. So that was probably rememberable and processable, right? Because these are familiar things. You know what a cat is, you know what loves is, and you know what cake is. So cat loves cake, in just half a second, you're able to see this, store it in your long-term memory, and process it with your working memory. That is because these things, cat and loves and cake, are actually retrieved from long-term memory. So your short-term memory here isn't doing, half a circle and a circle with a stick and then a cross and then a stripe and then another circle. No, your working memory is activated and your long-term memory is like, I know these letters. I know what that is. That is a cat. And then in your short-term memory, you just store cat. You don't store the individual letters or characters or the word. You just store the concept. And then this is just 3 things. So that easily fits within the limits of your memory. So the takeaway so far is that the more you know, the more you see, right? If you recognize words and characters, then you see more. You're able to process more. And what I've seen in companies, for example, in the onboarding process that my book also talks about, is that sometimes new people come into a code base. Maybe they're new to the programming language. Maybe they're new to the domain or to the code base. And then a more experienced person shows them the code base. Like, this is where we initialize things. And here's a bunch of API calls. And here's some UX logic. And then to them, it is cat loves cake. It is all so easy. But then for a newcomer, they might literally not be able to see and process all the new things. For them, it might be the weird language that we had in the beginning, or maybe if they're a bit more experienced, the individual letters. So remember that if you're explaining something to someone and they don't have that much knowledge about the language or the domain, then they don't see it. It isn't like they're not smart and they can't think. It is just because they don't see it, right? You're not smart, not smart because you couldn't remember the first sentence. Like that was the mean trick that I played on you there. But this exact same process also happens in programming. What I want to talk about further, dive into a little bit deeper, is a concept called cognitive load. So imagine you would actually try to remember this first sentence. It is shown here on the slide again. Then your brain sort of gets full, right? You're really like, a circle with a dot and a stripe and a sigma reverse and a diamond and a big C. It fills up your brain. You can almost physically feel that this is too much effort. That effort we call cognitive load. If your brain has to work really, really hard, then you're experiencing too much cognitive load. And cognitive load is also a topic that has been researched in science extensively, mostly by a professor called John Sweller that invented what we called cognitive load theory. The theory that your brain, like a processor, can be overloaded and too full to properly process again. Just like if your hard drive is full, then your computer doesn't operate so well anymore. So cognitive load theory describes that, and it doesn't just describe the fullness of the brain, it describes different types of fullness of the brain. Firstly, there is intrinsic load. So some problems are just inherently hard. We call this inherent complexity as well. And for example, if you have a triangle and you have to calculate the length of this third triangle, there's a certain complexity in that problem that you have to deal with. If you don't know how to square numbers, then you will never be able to find the solution to this. You have to know the Pythagorean equation to be able to solve this problem. We can't make the problem any easier. We can't make the problem so easy that it doesn't involve squaring and doing a root. That is inherent complexity, and that leads to intrinsic load that is part of the thing you're doing. But there's also a principle called extraneous load. This is load that is extra, that's coming on top of a problem. If we stay in the math space a bit, we have a programming example later. If we stay in the math space a bit, maybe you know that in many math books, problems are more commonly phrased like this, right? They don't put the numbers on the sides, they put the numbers somewhere else using a variable. And then there's extra text as well, like consider these values for Amy. Extra fluff. You see that this extra information is making your brain fuller because you have to read this. This is going in your short-term memory. You have to do some processing because the 8 is the A, okay, and the B is the 6. This is taxing for your working memory, but isn't really changing the problem, right? You're still doing the same equation. And then there's a third type of load called germane load. And germane load is good load. That's the type of load we want. You always need a little bit of room in your brain left to actually store information back into the long-term memory. So if your brain is too full, you can't remember anything. If you have a little bit of load left, then it's more likely that you will remember something. And so again, going back to the sentences, it's kind of likely that if I call you up tomorrow and I ask you what was the sentence, you will say, well, it was cat loves cake. You had processing power left to remember that sentence for the long term. Whereas for the first two sentences, it didn't even register. Your brain was so busy that there was no germane load left to store the sentence. So that's the thing that we use to store information in the long-term memory. Sweller did some spectacularly interesting experiments using cognitive load. In one of his papers that you see here, he had two groups of students do algebra equations. So the two groups did the same algebra equation, stuff you might know from high school as well, like a is 7 minus 4a. What is a? The first group just did the exercises. The other group got, as you see here, recipes for the exercises. So they got specifically information. Oh, if you have an equation of the shape a is b minus ca, what you can do is you can take the ca and move it to the other side of the equal sign, or you could always divide both sides by the same term. So they really got a recipe to how to solve the problem. And these recipes are called worked examples. And then they did the same equations as the first group. There was no difference between that. Sweller then compared how well these two groups of children did on these exercises. And the recipe group did way better, which you might say, well, that's not very surprising because they got literal recipes, right? So of course they did better. But they also did better on different new problems. And that's kind of interesting because in programming, in many fields, we have this idea that you shouldn't give people recipes, right? If people are seeking information about your code base, you shouldn't just give them the information. You shouldn't just tell them how to get it. They should figure out how to find the information. And what Sweller discovered here is that if you have people practice recipes, practice worked examples, they actually learn strategies that they can then later apply in other problems as well, right? Because stuff that's in the recipes, like taking a term and moving it to the other side of the equal sign, but then flipping a plus to a minus, you can use that strategy in many different situations, not just in this specific exercise. So one takeaway here is that sometimes it can actually be good to give kids, but this is true for adults as well, to just give them a strategy, just to tell them this is how you do something, rather than have them figure out stuff by themselves. So what we think happens here, we don't really know everything about what happens in the brain, but the hypothesis here is that this group used their germane load to store strategies. They weren't so involved in the problems, just a little bit, just enough to also have room left to store these strategies, like taking a term from the one side to the other side, into their long-term memory, and then being confronted with different problems, they were like, oh, I know what I can try. These are some strategies I can apply. And the other group was so busy that they couldn't remember anything, just like you were very busy in the beginning with the complicated sentences. The big takeaway here is that you don't become an expert by doing expert things, right? It makes so much sense where you say, oh, if we want kids to be good problem solvers, we should let them solve problems. If we want people to be good programmers, we should just let them program a lot. But that isn't necessarily true. If you're somewhat of a beginner, then getting help, getting these trainer wheels in the form of worked examples, the recipes, is a better strategy for learning than just exploring for yourself. Only if you've really reached the expert level, it starts to make sense to learn by exploration. So now wrapping this all back up to programming, right? Because we talked about kids and we talked about math. What does extraneous and intrinsic load have to do with programming? So for programming, I would say that extraneous load is the most important load that you can do something with. If you're solving a hard problem, then it's just going to give you intrinsic load. But extraneous load is something that you as a programmer have some control over, because you can rewrite programs to fit your prior knowledge better. Remember when we had the algebra exercise, you can decide if you put the numbers here with the text, or that you take the numbers and you put them on the triangle. This is something you can do for code as well. And now we are at the core topic of this talk, a cognitive refactoring. Consider this code in Python. Suppose you are filtering out all customers over the age of 50. So that's what you want to have in a list. You're filtering in, actually. So you're taking all customers over 50. If you're an experienced Python programmer that has lots of experience with list comprehension, for you this is very easy. This is just Gadlov's cake. It doesn't take you any energy to read this code. But if you're not so experienced in Python, or if you haven't seen many list comprehensions, this might be tricky because it's sort of weird. There's something like a loop that is a for, but it's sort of in the middle of a list. What is going on here? And you can figure it out, but it will take you a lot of energy. What you could also do is rewrite this code, right? You can say, okay, so what happens here is I start with a list of names. First it is the empty list. Then I loop over customers. And if the customer age is bigger than 50, I add it to this new list. These two snippets of code are equal to each other. They're doing the same thing. But if you don't know list comprehensions, the second thing is a lot easier for you to process. And of course, this isn't about this specific snippet. Imagine we're in a situation in which you have to figure out a larger code base. Then all of these list comprehensions are just gonna trip you up and not add anything, because they're far away removed from your own personal prior knowledge. So I call this a cognitive refactoring. It is a refactoring because the external behavior of the code is not changed, but it is not a refactoring as we typically use it that is meant to improve the structure of the code base. That's usually why we do refactorings. This is a refactoring you really do for you. You take the code, you move it towards your prior knowledge, you lower your own extraneous load in order to understand the code. And my book chapter has many different examples of cognitive refactorings. Another one is inlining a method. So from the perspective of readability, you want to have small methods that call each other. But from the perspective of understandability for you, a novice in this code base, it's actually not ideal if all the methods are linking to each other, because all of these hops where you have to take your debugger or you have to read through the code to find something, it's all adding to your memory. It's all increasing your cognitive load because it's all information you have to keep in your memory. What you can do, and many IDEs support this as well, is just take a method, you just inline it. You just take all the methods, you inline everything until you have a linear line of code. That is, of course, not preferred for maintainability purposes, but for understandability purposes, it can be really, really nice if you have all the information together, you get a sense of what's happening, and then, of course, afterwards, you just throw away this branch and you go back to the normal situation. So that is what a cognitive refactoring is, and that is why a cognitive refactoring is useful, because it helps you lower your own cognitive load. So that's it. That was my talk today. If you want to know more, of course, check out my book called The Programmer's Brain. I have a link at the end of my talk that has chapters. We sort of covered 2 chapters. Now it has a chapter about all these memory systems and what they mean for programming. And it has a chapter about cognitive refactoring, but it also has chapters about onboarding, code smells, variable names, but all from the perspective of cognitive science. As I said, that's everything I wanted to share with you today. If you want to know more, you can go to my website, felienne.com, or follow me on Twitter under @Felienne. If you want to know more about my book, or if you want to start reading straight away, you can go to felienne.com/book. You can immediately buy the ebook that is already available at this time. You can also pre-order the print book that is set to come out somewhere this summer. Maybe you're wondering also, by the way, like what happened to the kids? So you started to teach kids and then you were failing and then you started this whole adventure into cognitive science. So what happened with the kids? Well, Some of them dropped out, sadly, but many of them stuck around while I was improving myself. And out of this exploration that I did into cognitive science, two things came out, actually. One thing that came out was the book that you can now order, but the other thing that came out was a programming language for kids. Knowing everything I know now about how kids learn and about cognitive load, I figured out that programming languages aren't really doing a great job of lowering cognitive load. So I made a programming language that's based on what we know about learning, called Hedy. So if you are teaching children, or if you're considering to teach children, I'll be very honored if you want to check out my programming language as well. You can find the information on felienne.com/Hedy, and Hedy is free and open source, so we're not selling you anything there. And Hedy is at this point available in many different natural languages: Dutch, English, Hungarian, Italian, Spanish, French. So wherever you are, your kids and you can enjoy Hedy in your own natural language. If you really like listening to me, there's one other thing you can do, because you could also listen to Software Engineering Radio. That's a podcast that I'm one of the hosts of. It's a weekly interview format where we interview people about building systems, about programming languages and databases, but also about soft skills that are related to programming, like how to do a job interview and how to get better at presentation or documentation. So if you want to check that out, SE Radio is available on iTunes and Spotify. Thank you so much, and I hope you enjoyed the rest of the Manning Conference today.
Being more productive. What does that mean? Everyone has their own meanings and rules. In today's session, I'll talk about the 20 IntelliJ IDEA features that has helped me to become a more productive developer, or should I say to develop my applications with pleasure. But there is much more to IntelliJ IDEA than what I cover in the next 20 minutes. Check out our website and download IntelliJ IDEA today. Let's get started. Quick introduction. I work as a developer advocate with JetBrains. I'm a Java champion and author of multiple books on Java. I also lead Daily Java User Group and Women Who Code Daily, where I also lead the publication of Technology Grid, which is our monthly newsletter. Whether you are new to IntelliJ IDEA, switching from another IDE, or a long-time IntelliJ IDEA user, you should know how to personalize your UI to start with. This is how I see a lot of developers using IntelliJ IDEA to code their applications. But when I work with IntelliJ IDEA, I like to remove a lot of clutter in terms of the windows that I'm using and all the additional tool windows or navigation bars that I'm using, and also change the theme. So let me start with changing the theme of IntelliJ IDEA. So at present I'm using IntelliJ Lite, and I want to change it to a darker theme, which is Dracula. I'm using Presentation Assistant in IntelliJ IDEA, which would flash all the shortcuts that I would be using in this session towards the bottom of my screen with a green background, so that it's easy for you to see the shortcuts that I'm using. I can also install a theme without restarting my systems. Now let me get rid of the visual clutter that I mentioned. I'm using Find Action to remove all the clutter that I mentioned. I don't have to close the Find Action window to search for the other options. Okay, now I don't want to see the navigation bar. And what else is remaining? I don't want to see the main menu. I can turn this one off as well. Let me remove the tab placement as well. I don't want to see them. Of course, I have other ways to move around and navigate in my IDE. What remain here? Okay, the tool windows are, okay, the tool window bars, they are the vertical and the horizontal bars that you see on the bottom and left of your screen, so they go as well. Of course, you can get them back as you want them, and there are other ways to navigate in your IDE. Now, what remains is the project window, the run window, and the Maven window. I could get rid of all of them in one go by saying hide all the windows, or I could make them go away one by one, like Alt in 1 for my project window and Alt in N for my Maven window, Alt in 4 for my run window. So this is how you can quickly change the UI of your IDE. I can also change the view mode. Like since I often present my code, I use the presentation mode, which increases the font size of the code that I'm presenting. There are other modes, which is the distraction-free mode, full screen, and the Zen mode. And I would like you to work with them and let me know how they do. You can also add a background image to your IDE, and I often do that when I'm traveling and I'm missing my family a lot. So I click on OK here and here. This is my husband and my younger daughter. And if you think the image is getting much in the way of your coding, you can also change the opacity of the image so that it's not too intrusive. So this makes it be more lighter. IntelliJ IDEA has excellent integration with tools like Maven. You can even open your Maven projects by dropping the POM file to IntelliJ IDEA. IntelliJ IDEA is intelligent enough to understand that it's a Maven project and it has to be opened like that. So let me trust this project and open it in IntelliJ IDEA. You can view the structure of the POM XML using your editor. And I also like to drill, and I could use the next method or the previous method features to jump through the elements of the POM XML. But what I prefer is the structure view, which lets me jump to the groupings. Like I can go to the dependencies and I can go to the properties or the plugins. The Maven window lets me also view the dependencies of the dependency. And what's better, I could also view all the dependencies as a UML. This one's really exciting because this is one of the features that I really like in IntelliJ IDEA, because I can also try and I can also view the conflicts or the duplicates. That's really helpful when you are working with a bigger code base and you want to find out the cyclic dependencies or the ones which have the conflicts. You can also export this image to a file and of course share it with your team. You can save it and you can print it as well. The other thing that I like about Maven tool window is that I can define run configurations. I can define run configuration. I want to add a Maven run configuration and I want to name it as demo manning, and I want to execute the command as clean and verify. I can store this run configuration as a project file, and IntelliJ IDEA will ask where I want to store it. I can also commit the run configuration to my version control system and save it and share it with my teammates. Okay, let me go to the dependencies, and here I can either control click or I can use go to declaration feature, and I can drill down to the POM XML of the dependency that I have. So here I am in the POM XML of Hamcrest library. So I can drill down into the POM XML file of the dependencies that I have in my main POM XML file. If I go to my Maven window, I can also download all the sources. I can either download the sources or the documentation or both for a single dependency or all of them. IntelliJ IDEA has a 4-month release cadence, and it can very well keep up with the 6-month release cadence of Java. This essentially means that you get a lot of assistance when you try to use new language features in Java. Let's work with an example. Imagine you want to create a new type, say person. When I say Alt and Enter, which shows me the context action, IntelliJ IDEA knows that you can create a class person, or you can create a record person. Let me choose creation of a record. I choose the default destination package, and in this case, I also get the components which matches the constructor that I was trying to use. Let me change this as name and this one as age. In this example, I'm trying to use pattern matching for instance of, which is one of the latest Java language features. When I get a variable in another color, I know that IntelliJ IDEA has some suggestions for me, which I can access by invoking the context-aware actions using Alt and Enter. In this case, I'm selecting other, replacing other with pattern variable, and this is what I get. I can also use Alt and Enter and see if there are some suggestions which might not be related to the latest Java language feature or something that I want to do, but I could do. So in this case, I'm selecting merging of the nested ifs. Now I have another suggestion, which is simplifying of the if-else statement. So this is how I could use one of the latest Java language feature with assistance from IntelliJ IDEA. The next example is of sealed class, which lets us define secure hierarchies in a declarative manner. Before I seal a class and restrict which other classes can extend it, let me view the available subclasses of class plant. So this is how I can view the subclasses, or I could view the subclasses as list by using the type hierarchies. Now I can invoke the context action and use the option seal class, and in this case my classes would be sealed, defining which other classes are permitted to extend it. If I go to the definition of class climber, I see that it has also been modified. One of my favorite language features in Java is text blocks, which was again added in one of the recent versions. Text blocks allow you to define multi-line strings, which are a pain to define with the regular Java strings. So in this case, what I have in my example here is a regular string which tries to define a JSON value, and let's see how I can convert that to a text block with just a click of a button. So I just invoked context-aware actions, and now I'm choosing replace with text blocks. Now this is much simpler to read. One other thing is I can also inject a language or reference in my string values. So let me again select Alt and Enter, and I say inject language or reference. Since I know this is a JSON value, I chose the value JSON. Now if you can see at the end, you can see a orange underline which says that this value is incomplete or incorrect. Now, what I see missing is if I say navigate to the next highlighted error using F2, I can see that I'm missing a comma here. So when I inject a language or a reference in a string value, applies to regular strings or text blocks, I can actually work with my values which are in other languages like JSON or regex value, regular expressions, and much more. You also get code completion if let's say you are working with database queries. Another recent language features is the switch expressions. So in this case, I have switch statement, and I can convert this to a switch expression with just one click. If you have been working with previous versions of Java, moving to Java 8, the functional programming style, could be a challenge. In this case, IntelliJ IDEA can help. Let's work with an example. IntelliJ IDEA suggests that this lambda could be replaced with a method reference. This could come in very handy if you are trying to learn functional style programming. Now let me go to another example and see how IntelliJ IDEA can help. In this case, it says this for loop could be replaced with a call to collections.addAll. Live templates lets you type faster in IntelliJ IDEA with fewer bugs. You can use the inbuilt live templates in IntelliJ IDEA or create your own. You can use simple templates in IntelliJ IDEA, like using main to generate the main method. You can also use PSVM, which is the acronym for public static void main, to generate the same main method. The other frequently used live templates are SOUT for system.out.println. You can use a variation which is SOUTV to print out the value of the local variables that you define in a method. Similarly, SOUTP to print or to output the values of your method parameters, and a couple of others as well. You can also use the parameterized templates in IntelliJ IDEA. In this example, when you type FORI and hit tab or enter, you get a for loop with the parameters which you can replace to get the values to use the values that you want. You can use surround templates to wrap your line of codes. In this example, when you select this line of code and invoke Ctrl-Alt-J, you can select the option to wrap your selected code with. Creating a new live template is easy. Go to Settings, search for Live Templates and click on the plus button. Then select Live Template. Now, add in the abbreviation and the description and the template text that you want to be inserted when you use the live template abbreviation. In this case, since you have parameters, you need to define what they would be doing. I can also define the default values and click on OK. At the end, define the Java. At the end, define the context in which this live template will be applicable. In this case, I'm selecting Java. When I click on OK, I can write test and click and hit on tab, and I would see that the text that I entered for my live template has been inserted in place of text. Since I defined parameters for my live template, I can also modify their values, and of course I can also see the default values that I entered. Though I work with Java most of the time, I also use other languages which I can easily use in IntelliJ IDEA. I recently hosted my website using HTML, CSS, and JavaScript. So I have this project in IntelliJ IDEA, and like the code completion that I get in Java projects, I can get similar code completion for my HTML and CSS as well. I can also move around my project window and I can view the images that I have in my editor window. The other thing that I like about is that when I go to index.html, I can actually view the changes. I have a built-in preview in IntelliJ IDEA. So when I click on this, I can see the changes as they would appear here. And of course, I can also control click, use the usual navigation features that I'm used to working with in Java for the other project languages as well. Of course, as I mentioned in the beginning of the session, 20 minutes are not enough to demonstrate the features that I use every day, which are great for the developers. So I would quickly demonstrate a couple of features in the last 2 minutes. And for the rest of the features, I request you to go and check out our website and our YouTube channel, which has a hell lot of videos. IntelliJ IDEA, as I mentioned, lets you work with multiple languages. And when you're working with, let's say, your Markdown language documents, you get to see how the final version would look in your editor. So whenever you make any changes here, you can see the changes right here in your editor, which I think is really handy. When you're working with web applications, you can also use the HTTP client window to open such requests, and there you can execute this request. You also have examples just in case if you are not aware about how to create those applications, how to create those requests to test your applications. The other thing which I wanted to show you was the icons that you have in the Gupta window. They tell you about what kind of class that you're working with. And you can also click here to open your HTTP client window. And you can also view all the endpoints that you have in your web applications. Like this comes in. So this is a test, this is a demo application. Of course, it has just a couple of the endpoints, but when you're working with big applications, bigger web application, this window is quite handy. There are a bunch of things that I wanted to cover but could not, like creating new shortcuts, plugins, refactoring, inspections, code analysis, VCS integrations, test-driven development, profiler integration. You can find more about IntelliJ IDEA by using any of these links to access our blogs, Twitter, and YouTube channel. And thanks for watching.
Hi there. My name is Vincent, and I work as a research advocate at Rasa. At Rasa, we're working on open source tools to allow you to write your own virtual assistants. So a lot of our work involves a research team, one that I'm a part of, and my job is to make sure that the algorithms and tools that we have inside of our technology stack are well understood by our community of developers. And as you can imagine, in my day-to-day work, it is very important that I communicate concepts clearly. Now, communicating things clearly in the age of remote work does mean that it might be good to invest in some tools. So what I would like to do in this talk is just give an overview of some of the tools that I've picked up, such that hopefully you are also able to communicate more clearly to your colleagues and or to your community. So let's say that I'm making a video, and the point of this video is that I want to explain code, which is something that I tend to do on one of Rasa's YouTube channels. Well, then I can do a few things. I can use my mouse to say, well, I'm importing a module over here, and we can pay our attention to some of the numbers that are on display here. And although the mouse cursor works quite well, one thing that we should acknowledge is that the mouse cursor is quite small, and you really have to pay attention to where the mouse cursor actually is, and that can be a drain on the attention of people who are watching the video. So what I prefer to do is I prefer to use this app that doesn't just let me hover my mouse over something, it also allows me to effectively just draw. And there's a lot of benefits to this. Notice that when I draw a box around something that I'm importing, it's a lot easier to draw your attention to it. I'm also able to just squiggle under a little bit of code to emphasize that it's important. Note that it's also possible for me to draw some arrows. And what's really nice about this app is that I'm able to draw a circle, and after a few seconds it goes away when I lift my mouse cursor up. It's little things like this that can really help capture people's attention because it feels like I'm lecturing and drawing on a whiteboard again. And it's that feeling of a whiteboard that I think a lot of people are really missing when they're collaborating real-time in an actual office. Now, the app that I'm using for this is called ScreenBrush. And here's the widget that pops up whenever I hit Alt-Tab on my machine. Now, I have a dual screen setup, so typically when I'm actually recording, you don't see this in display. But what's also really nice is that I can toggle it on and off whenever I feel like it. In general, I think these squiggles are perfect for what I'm usually trying to do. But it is also good to observe that there's also tools for like actually drawing arrows. I can also draw boxes. And there's also an option to actually write some text. Another thing that's quite nice is that I'm also able to draw in different colors. So, for example, right now the background is white, but if the background was, say, darker, then I can use maybe a green marker to emphasize something that you can look at. But what's also a great feature is that there's a shortcut that allows me to keep my drawings intact. Now, pay attention to the stopwatch over here. And again, notice that it's great that I'm able to draw this arrow, right? It's great that I can draw your attention to this one particular part. But notice that when I press the F button on my keyboard, that then the hourglass here changes. And I'll also notice that if I move my mouse cursor up, that the arrow is still there. Not only am I able to draw attention to something, I'm also able to literally draw over the entire screen. And that allows me to actually explain a concept whenever I need it. Very often when I'm talking about code, then I'm sometimes also talking about other concepts that are happening in the background. For example, maybe I'm explaining that we have a main Rasa server that has to communicate to a database via the Rasa SDK. And in this case, I can also explain that there's a separation of concerns, and explaining all of these concepts is just a whole lot easier when you can have both the code on display as well as some of these other drawings. Now, what's also really great about this app is that I can press Ctrl-Z to my heart's content, so I can remove drawings that I've made. And there's also some other useful shortcuts as well. I'm able to take things that I drew earlier and move them around. I'm also able to use a scissors tool to cut certain parts away. There's a lot to like here. And what I hope is clear is that the usage of this tool isn't just limited to explainer videos. This can also be great during Zoom meetings. Especially if you have a one-on-one and you really want to get down to some details, being able to draw is a very natural way to get ideas across. But let's now talk about a very human benefit of using this tool to explain things. What I'll quickly do is I'll press W, which is another shortcut, and basically this makes the whole screen turn white, so the screen actually becomes a proper whiteboard. I will now also press F to make sure that my drawings stay here. But what I can do now is I can say, well, let's talk about this one concept. Let's say that I want to explain an architecture diagram. And it's relatively simple, so I've got a Rasa server over here that is dealing with natural language processing tasks, let's say. And let's also assume that it has to communicate with another backend. I will call this the Rasa SDK. And it will be this service's job to talk to databases. And by drawing this like so, I hopefully made this distinction clear, and the fact that there's a separation of concerns, let's say. Now, notice that because I'm drawing on an actual whiteboard, that I'm able to explain a concept as I'm drawing. And this has one amazing benefit. The drawing determines the pacing. You might recognize the feeling that you can get when you see a PowerPoint presentation where big architecture diagrams are drawn in one go, and it takes a while before you're actually able to process what exactly you're looking at. Because you're drawing from scratch, you are also forced to tell the entire story as a presenter. And it also means that it's hard to go too fast. Because you have to draw everything, it also means that concepts have to be introduced one by one, which, from a teaching perspective, is a great constraint to have. And I hope it's easy to imagine that if you force yourself to actually give a presentation via a whiteboard, that the ideas tend to stick a bit more because they've been properly introduced, because we're not going very fast through all the different concepts. Now, note that another cool feature from this package is that the drawing that I just made might be very conceptual, but if I now press Alt-Tab again, I'm back into my code notebook. And if I want to go back to the concept again, I can now hit Alt-Tab again, and the whiteboard just pops up again. I'm able to make a drawing of something that will keep in memory for a while that I can refer back to. And that's also really great when you're trying to explain something at is very technical and perhaps also very complex. Now, at this point, you might be wondering, how is this guy drawing so fast with his mouse cursor? And the truth is, I'm not using a mouse cursor. I actually made the investment to buy a Wacom tablet for this use case. There are a lot of these tablets out there. I believe you can also use your iPad for this, but I really like the Wacom tablet because it's really good for just this one thing, which is drawing. The tablet specifically is the Wacom 1, which I believe is the cheapest one in their line of drawing tablets where you can see the drawing that you're making. But I don't want to suggest you need this specific tablet. There's also cheaper ones out there, and the main goal here isn't to buy fancy hardware, it's just to be able to make drawing a little bit easier, because drawings are just a great tool for communication. And I would like to give a couple of examples where I've been able to add drawings, besides just in my live videos, to get concepts across better. So here's an example question from the Rasa forum. This is a place where our community members can ask us questions about anything related to Rasa. And there's a particularly good question being asked here. It's about this machine learning model that we've made, and there's a user here that's asking about details about this very specific edge case where there's only sparse inputs going in. And this is a great question, but how do you actually give a proper answer to such a question? Well, one thing that you can do is you can grab the architecture diagram, which is what I'm doing in my answer below here. And next, what I'm doing is I'm taking it apart. I'm removing concepts that aren't necessary, so parts of the architecture wouldn't be relevant. And again, I'm able to highlight where the developer needs to pay their attention. And it's this extra bit of context that is very helpful. By having a drawing here that specifically tells you what to pay attention to, will also tell you what I am talking about. So there's less noise in the communication. There's just a bit more clarity. And the nice thing about making drawings like this is that if there's still something that's not unclear, it's also easier to get a precise question that is being asked. And that's actually what happened in this conversation. The user is now actually using the same diagram that I made to zoom in on a specific part of the diagram and can therefore also request my attention to go there. Which is exactly what happened. I then also started zooming in on the part below in this architecture diagram. I came up with a drawing that serves as an example, and then below I give even more details where we can talk about the precise numerical operations that are happening. And what's great when this is on our forum is that it's not just this one user who's asking the question who will be helped by this, it will be our community at large. This answer will be saved for other people to also enjoy. And again, I just want to stress, what's really helping here is not just the fact that I'm willing to give an elaborate answer, but also the fact that I'm able to make these precise drawings. I really like to think that it's the clarity that you get from a drawing that's 80% of the result here. That's not to say, though, that a drawing on its own is enough. It really also helps if you're able to think about the story that the drawing is supposed to tell. So let's now talk about a few examples from documentation pages. What you're looking at here is the GitHub repository for an open source project that I maintain on behalf of my employer Rasa. Now, the goal of this project is to make more natural language processing tools available for Rasa that support non-English languages. And there's a couple of tools that are relevant. We have tokenizers, for example. But the downside of saying, well, I have tokenizers, having tokenizers is great, but maybe if you're just starting out, it will be nice to remind people what a tokenizer actually is. And for that, the easiest thing you can do is just add a little drawing. Now, there's a lovely little conscious thing that does happen here, though. What a tokenizer does is it takes a string as input, and it outputs a list of strings as output. The idea is that a sentence goes in, and separate words go out. What some tokenizers are able to do is do more than just split the text, though. Some of them are also able to lemmatize. Now, the example that I have here shows a sentence that is tokenized, and then the same sentence that is tokenized and lemmatized. What I'm going for here is that because I have two examples that use the same sentence, that there's also a very clear contrast between the output. A user who's not familiar with tokenization and lemmatization can look at the drawing and start wondering, well, what's different about the output here? And the hope is that by having a drawing like this, we are able to give the user enough intuition with a single example that we don't have to fully explain what lemmatization actually is. And notice that we do the same thing for featureizers. And we also do the same thing for fallback classifiers below here. Adding some drawings to your documentation can really also make it easier for people that are perhaps slightly less familiar with your domain, in our case natural language processing, but are still able to explore what the package is about. What's really great about these drawings is that you're able to get a concept across without having to resort to jargon. Jargon is great, but only if you're on the inside of a domain. For anybody outside of a domain, jargon can be rather intimidating. And I would argue that adding drawings can be a great way to alleviate this. What you're looking at here is an open source package that I maintain personally. The name of the tool is called Klumper, and the whole point of it is that you're able to more easily deal with large chunks of JSON files. The library isn't doing something particularly fancy, but when you consider all the operations that you might be able to do on a JSON object, I hope you agree that it would be nice if we can add a couple of drawings that explain what's happening. So if you go to the API, for every command that I have in this library, I've also added a drawing that shows you what the operation actually does. So for example, let's go to the flatten keys command. The drawing here shows the representation of the data before and after the operation. And I don't just have this for the flatten keys method. I pretty much have a drawing for every method that is in here. And again, the whole point of this is that we still add an example below so you can in more detail confirm your belief of what should be the output. But a drawing will just be so much more intuitive because you can just eyeball what's going to happen. And this is what I think contributes to this package being easier to pick up, which is exactly what I'm trying to achieve in my documentation. Now, I've given you all sorts of examples for documentation, and I would like to think that these examples are great when you're in developer advocacy kinds of roles like I am. But I also want to emphasize that being able to draw is great when you're working on an open source project or together with a colleague. Here's an example of an issue in GitHub where I'm trying to explain what I think a certain component in a machine learning model should do. Sure, there's a lot of context in text that will explain what exactly I'm doing and why, but the awesome thing about having a drawing, again, is that my colleagues and collaborators can more easily pinpoint where I might be wrong, and it just makes iteration faster because we're spending less time communicating because we only need one or two of these pictures to get the ball rolling on an idea. Now, in this case, I'm showing more the mathy parts of communication, but I would also argue that making some of these drawings, they're also great for building user interfaces. Here, I'm making a mental note for myself for this user interface element that I'm working on, and I just want to highlight the important parts. The thing that works really well for me when I'm building UI components is that the level of detail on a drawing is just right. I don't spend too much time making a perfect drawing or a perfect Photoshop that's pixel perfect that someone has to follow, but I am able to be expressive enough to emphasize which parts are really important. There definitely has to be a selection element in my parallel coordinates chart, and I really want to attach color based on the columns, and there needs to be a UI element for that. And a drawing like this is enough to get started quickly and iterate on. Not too many details, and basically that whiteboard feeling is something that you have again if you just incorporate more drawings. And it's that feeling that I really like having again, especially when we are doing remote work. Now you might think at this point, all of this is great, but do I really need to buy a drawing tablet? Is that what I need to do? Well, maybe not. If you want to get started getting clarity across, the main thing that you want to think about is just what picture do I want to draw? The main thing I'm trying to do here is get the right concepts across. And I would certainly argue that drawing definitely helps, but if you don't have a drawing tablet, maybe it's enough to make some of these elements inside of your favorite presentation tool. Keynote, Google Slides, or PowerPoint, they all have pretty good support to just make some boxes with text appear in them, and that can already be sufficient to get a pretty good drawing going. Simply make a screenshot of all the components that you're putting in here, and that can readily be shared inside of GitHub, on a forum, or on Slack. In particular, if you're going down this route, there's also this other app that I can really recommend. It's an app that I do pay for, and it's called Noun Project. Effectively, any kind of noun has a black and white icon that you can just copy into a presentation. So let's say that I'm interested in doing something of a database. And sure, this one looks nice. I can just drag it in and use it to my heart's content. In this talk, I've been highlighting a couple of tools. In particular, I have my little Wacom tablet, and I'm using an app called ScreenBrush right now. But I hope that there's also a lesson that I'm able to get across that's a little bit more on the meta side of the spectrum. These are just tools, but the end result is that we achieve clarity. If you're able to communicate clearly, there's less communication necessary, and you're typically able to just get more done in your day. However, if you want to achieve clarity, it does mean that you have to use some of these tools consciously. You have to try to think ahead and think, well, what kind of person might see my drawing, and what are some of the more confusing concepts? The tools that I'm talking about here are just tools in the end, but the main thing you want to make a mental note of is that empathy is actually maybe the first thing that should pop into your mind. If you can really imagine what it's like for someone not to understand the point you're trying to get across, then that understanding is going to contribute more to the clarity over here than any of these tools will ever do on their own. Having said all of this, I do hope that you give some of the techniques and tricks that I've shown in this video a try. Especially in this era of remote work, it can really be helpful if we can just get a bit more clarity and a bit more calm in our day-to-day. I really like to think that the techniques shown in this video have made it easier for me to communicate to my colleagues and to our community over at Rasa, but if you have any questions about anything shown in this video, feel free to reach out.
Hello! Today I'm going to be talking about balancing developer productivity and security. It's a topic that I think that we don't necessarily think as much on. Usually the balance of developer productivity and security is off. We usually favor one or the other. Developer productivity really measures how fast we can deliver software to production. The more productive you are, the more software that you can deliver, the more features that you can deliver, and the faster your cycle time from the point that you think of the feature to the point that feature is in production. But there's usually a problem. By the time the feature gets to production, there's a security checklist that we've forgotten all about. We have a security checklist that thinks about whether or not we have open networks or ports. We think about whether or not we've added certificates for encryption. We think about whether or not we've removed development access to production data. This is particularly important if you have an application processing production data and you don't want developers accessing it directly. You also forgot whether or not you should check for vulnerabilities on the host machine that you're running the application on. Applications themselves don't just run on thin air. You have to be able to check whether or not there's vulnerabilities in the code and the machines or containers that they're running on. You have to check whether or not the application has root access, right? Otherwise, if someone has access to the application and manages to exploit it, they might be able to exploit the underlying operating system. So there are a lot of attack vectors that you need to consider, and the security checklist is in place to make sure that you don't violate any of these potential rules. And it ultimately mitigates the blast radius and eventually the attack surface of how someone might exploit your application. This is just a security standpoint. This doesn't even include some of the compliance stuff you might have to have. If you're in, let's say, Europe, you might have to comply with GDPR. If you're in the US, you might have some compliance and regulation on how many approvers you might have for production. The reality is that after this checklist, you realize that 6 weeks later, you're still not in production. The point is you forgot all about these pieces on the checklist, or you just didn't know. And now your developer productivity has been affected. You don't have the feature that you need in development or production for that matter, because you're still trying to figure out why a security or compliance requirement broke your functionality. So how do you balance delivery and security? Well, it's a question that I had to ask myself a lot, especially as an infrastructure engineer and now a developer advocate. I work for HashiCorp, which develops a lot of the infrastructure as code and infrastructure automation tooling today. I'm the author of Essential Infrastructure as Code. And if you would like to get in touch with me, you're welcome to find me at these handles as well as the website below. And most of what I focus on is how do you balance getting the delivery pace to match the kind of security stance that you want to have in your organization. It's a really difficult balance, but I discovered that there's actually a bigger problem, and it's not about security, and it's not really actually about developer productivity either. It's about education. Think of it this way. We address the known knowns about our applications and systems using testing. So we test for things that we know and we expect to find. So for example, if my feature or if my system should have this functionality, I know to test for it. We also test for known unknowns. Known unknowns is what usually people focus on for monitoring. So if our CPU increases, well, we want to at least know what's happening, right? It's unknown until we actually go and we find out what's happening and what the information we need. So that's what monitoring is supposed to cover. These days, we also have observability, which is focusing on the unknown unknowns. Observability allows you to examine something you don't know and make sure that you get the information that you need. So you might not know what you're looking for, but at least you have the information that you can find. Then there's this unknown category of unknown knowns. And I know it's a little complicated, so bear with me, but unknown knowns are what I think about as security and policy. It's something that someone else knows, right? It's siloed knowledge. And this is where our problem resides. Most of security and policy are unknown knowns. And the problem is an education problem. We need to be able to teach the unknown knowns across the organization. And that's why developer productivity and security are imbalanced at times. It's because as developers or engineers, we may not know what we don't know about security, and we need to learn a little bit more about it. So how do we solve this problem? Well, one solution is to use something called policy as code. Policy as code is the management of an organization's policies with code to ensure the conformance of changes. So if you can imagine this process, the idea is that you want to first check if a change conforms to our organization's policies. This is a little bit counterintuitive, right? Because most of the time, as a developer or engineer, you're building some functionality, pushing it to production, and then you check whether or not it's conformed to some policy or some security. So what this is saying is let's move this as a first step, which is let's check if the change actually conforms first before we actually push the change. And once we push the change to production, we can have a second subset of things that checks if the environment conforms to our organization's policies. The latter half of this flow usually focuses on reporting and auditing. So if the environment does not conform, then we take remedial action. But policy as code describes both ends, right? It describes the first half of it, which is let's check if it first conforms, if the configuration or change that we're making even conforms to anything that we're looking for our organization. And then we can check whether or not the environment itself needs to be remediated for anything. The thing is, policy as code is just one term that refers to this. In the time that I've spent working in this space, I found out a lot of people use different terms for this. So you'll also hear shift left security testing. It's borrowing from the approach of general shift left testing, which is to test the configuration before production. Similarly, in this case of security testing, you're testing for secure configuration or compliant configuration before production. There's also fitness functions for architectural conformance. This is along the lines of evolutionary architecture. I won't go too much into it today, but the idea is that fitness functions measure how far away you are from architectural conformance. In this case, we're talking about security conformance. There's also this idea of static and dynamic analysis for security. Most tools in the security space separate themselves as static analysis or dynamic analysis. Similarly, policy as code is actually both, because what you're doing is configuring the rules for these static and dynamic analysis tools using an infrastructure as code approach. As the author of infrastructure as code, if you're curious to learn more, you're welcome to ask me more about what infrastructure as code specifically is. But the idea is that since your static and dynamic analysis tooling is part of your system, you should treat it as extended infrastructure, and thus you should configure the rules with an as code approach. The other important part about dynamic analysis specifically is that it's focusing on continuous verification or remediation. And that counts. You need to be able to specify the rules and version the rules you want for verification and remediation. So for example, if you maybe loosen a remediation rule, right, saying we don't want to have anything in our running environment to have root access, you might want to adjust that rule. And in that case, you should probably do that as an as code approach so that you can communicate to someone else and teach someone the rules that you do expect for remediation as well. All right, so let's try it. I'm going to actually do one example of how you would treat policy as code. Let's say I'm an engineer and I want to update a network policy rule. This network policy rule should allow all traffic to all ports from 172.16.0.0/16. If I update this policy rule, I am basically opening traffic from 172.16.0.0 to all ports. So there's something that I need to think about. Do I want to do that? Should I do that? And actually, my organizational policy tells me, hey, we don't really want you to do that. My organizational policy is no network policy should allow traffic to all ports. Basically, the security team wants you to be really specific about which ports the traffic should access. So in this case, if I try to make this change and I check if the rule conforms to the organization's policies, I actually should fail, right? So this should flag it as a problem right off the bat. And that way I can go back, fix it, and then eventually make the change, push it to production. And from a remediation standpoint, which is the second half, the more dynamic analysis part of this, I don't necessarily have to check if the network policy configuration conforms to the organization's policies, as much as just someone maybe manually going in and updating the rule, and then maybe there's remedial action that needs to be taken. But both sides will effectively be addressed by this one policy, and it will check the same kind of change. All right, so before I go into the actual code base, what I do want to state is that most policy as code tooling uses pretty much one mechanism. Policy as code tooling grabs the state of a system. Usually the state of the system comes from an API, from the infrastructure runtime. It could come from the application. There's a lot of different places that you can grab state, but state is usually expressed in the form of JSON or metadata format. So that JSON or metadata format is parsable. The result is that most tools first parse for certain fields, and then they check the field values for whether or not they conform to some test policies that they have, and the tests pass or fail. The reality is you can implement your own policy as code tooling. That is what I'm doing today, but the focus, at least for parsing through some of these fields and the abstraction, is that it makes it easier if you have a pre-existing tool that parses for the right fields, right? So most tools are just going to make it really easy for you to parse the right fields that you're looking for, rather than you looking at the JSON and trying to figure out the right schema that you need to get to. All right, so let me switch the demo. All right, in this demo, I have a setup for the network infrastructure rule. The network infrastructure rule is an AWS security group for those who are more or less familiar with Amazon and infrastructure and cloud providers. This Amazon security group rule is basically the configuration I plan on pushing to production. Notice I have the CIDR block of 172.16.0.0, and I have decided I'm going to open my ports from -1 to port to -1. In AWS security group, the API uses -1 to denote all ports. So I have my policy check here. I've already written this policy as code. The policy as code is trying to be as expressive as possible. As a general rule, I try to make sure that if someone is reading this who doesn't know any better, they would be able to understand what's going on. Again, communicating the unknown knowns to someone else. So in this case, I have a network policy check that says policy should not allow traffic to all ports, change to range or specific port. So there's two parts to making sure you write good policy as code. The first is make sure you're clear on what the policy is. The second is change to range or specific port, which is the action. Like, how do I take action to fix this problem? So in this case, I read in the configuration for the AWS security group, and then I'll parse through some of the attributes. And what my test will do is test that no network policy should allow traffic to all ports. What this is doing is it's going to check the to port field and the from port field for this -1, which means it shouldn't have all ports. If I run this test, I expect it to fail, right? Because this policy is saying that I should not have all open ports. And it's actually what it refers to, right? So it prints out the policy should not allow traffic to all ports and then change to range or specific port. This is really important. It tells me that this has failed. So as someone who's an infrastructure engineer or developer who's doing this, what I'm going to realize is, oh, I didn't pass this policy. This is a problem. Let me go in and let me change my configuration. So I'm going in, I'll change my configuration to 5432 because this is my, let's say, it's PostgreSQL or something. It's a database port. So I'm going to be really specific. And let me run the test again. When I run the test again, the policy passes. It means that I can actually push this to production. I can add this to a continuous delivery pipeline. I can add it to any automation I have that verifies tests or checks for information before going to production. My approvers are able to see that these tests have passed. My security team has some peace of mind because they know that it's secure and this is checking before it goes to production. So this is where the power of policies code helps communicate these changes, right? I don't necessarily have to go to a huge document and figure out what policies I should have in my infrastructure and how. Instead, I'm able to use the policies expressed as code, run them against my configuration, and ensure that it's compliant from the very start. So in summary, the focus is to use policy as code to drive secure developer productivity. Rather than make this narrative about balancing developer productivity and security or having one or the other, drive secure developer productivity from the very start. The idea is that if you can bake security into your development process, it makes it easier for you to scale your security knowledge across your organization and even compliance knowledge too. Some general helpful practices I recommend when you start doing policy as code. Version control, if you're familiar with infrastructure as code, the practices are very similar. You want to version control all of the policies that you have. That way you can refer to any changes that have been made, and you can always revert changes to policy as well. Make sure your policy is descriptive. As I mentioned before, someone should be able to understand the type of policy and how they can take more actionable behavior to remediate it. On top of that, you can identify mandatory versus advisory. Not all policies are mandatory. There's a nuance to this in that you may not want every vulnerability scan to fail if the output is always high, right? So if there are high vulnerabilities or high CVEs in a container image or a virtual machine image, well, does that mean that it should always fail? And the answer is not always. You have to identify which policies are more mandatory in nature and which ones are more advisory. In addition, manage policies as libraries. I recommend bundling the policies together and sharing them across your organization as libraries, making sure people can iterate on them. And make compliance and security accessible. It's okay to keep these policies in some ways open, right? You want people to understand the kinds of security posture that you expect them to adhere to, especially from a development standpoint. So even if it means from a compliance standpoint, you expect code quality to be a certain percentage, add that to delivery pipelines for applications so that it is accessible for someone to be able to test and recognize when they have a problem. If you're curious to learn more, you can always check out this GitHub repository that I have. It has some more policy as code examples. You can also check out this video from OWASP DevSlop about testing security and shifting it left. And if you want to learn more and have greater detail about how this fits into infrastructure as code, there is a policy as code section in my book. And you can find these slides at my personal website below. So if you're curious to learn more, definitely reach out to me, and I appreciate you tuning in today.
Hi, everyone. My name is Michael Mikowski, and I'm one of the founders of Kubuntu Focus. With me today is Erich Eickmeyer.
Hi there.
Who leads packaging and community integration. He's also the project manager of Ubuntu Studio, and although his cape is hidden, he is a master of the universe for Ubuntu. No hyperbole there at all. Today we're talking about Linux desktops. Now, before we go any further, let me say this up front. This is not for everyone. If you are a consumer who depends on MS Office or the Adobe Suite for the majority of your job, or you just don't want to be that guy sending messages in green bubbles to your friends, then you are probably better served by some other OS. However, if you are a researcher in robotics or machine learning or a DevOps manager, content creator using world-class tools like Blender, or a developer for supercomputers or the web or autonomous vehicles or IoT devices, then a Linux desktop can be far more productive than just about anything else. The key, though, to finding this nirvana is ensuring that your system is properly curated. A great example is Kubuntu, which is used by developers all across Google. Let me show you a video that illustrates how we create a highly curated system and how you can too.
The first component of a curated system we want to discuss is the welcome wizard. Even if it's just you, writing a tool to initialize your system on the first sign-in is almost always a great idea. First, it will help you document and install your system much better, and the barrier to entry is very low. Second, if for any reason you need to reproduce your system, like when you add a new device or your old one goes in for service, this tool will save you hours. And when your team grows, your wizard can be constantly used and enhanced by everyone. Great subjects to cover are where users can find repositories, how to connect to the internet or shared drives, how to change encryption passphrases or the user avatar, and how to install the preferred IDE. It's also a great way to introduce users to the apps they will want to use. Ironically, we think you should work to minimize how much you need to add to the welcome wizard in the first place. For example, instead of directing users to configure apps or optimizing their GPU, configure the apps for them before they even sign in. Instead of directing users on how to optimally install software, create packages to make this obvious and easy without instructions. We will talk about these and many other opportunities later. However, some first-run guidance will always be needed, so don't miss this great opportunity to get yourself or your team off to a great start.
All right. Thank you, Erich. Now, let's bring it back over to this side so we can talk about how shared tools can liberate you so you can focus on what you do best. Now, not surprisingly, we suggest you create and share tools within your team instead of having every developer hack their own. If you're running Linux and you wrote these tools well, then you'll be able to use them directly in production with little or no change. And that's a big incentive with a surprisingly large payoff oftentimes. What these tools accomplish may vary a bit from team to team, but here are some that we have found especially useful. A GCC version selector, which is real handy when you have libraries which require a specific version of the compiler to work. A power profile selector, a video tearing preventer, a keyboard color selector, a command line bookmarking tool, and a system check and repair tool. All of these people love and use every day, and it saves them time. Now, robust and complete tools require lots of planning and coordination to maximize their benefits. Here are the attributes we think all shared tools should have. They should have a unique icon and be easily found in the Start menu. They should catch and handle errors well. They should work within a GUI or with a command line interface. They should install packages inline if needed. They should be developed with source control management and test-driven development to ensure quality and prevent regressions. And of course, big surprise, right? They should be distributed and updated using the package system. Now, we know this is a big undertaking, but the payoff can be fantastic. We suggest you start small and build as you go.
The next step that can really make a difference is optimizing for the hardware. Linux generally gets a bad rap for desktop hardware compatibility, probably because so many people try to install it on incompatible hardware. Those who try this don't lose a computer, but they do gain a hobby. Don't do that. Instead, buy hardware that is supported by reputable vendors, and your experience can be far better than other platforms. Consider what you can do. You can upgrade the memory and disks after you buy your computer with a single standard Phillips screwdriver. You won't need to pay a 400% markup on RAM or disks. Get NVIDIA RTX GPUs that are up to 30 times faster than proprietary Unix developer vendors. Get lots of ports without the dongles and adapters. USB-C, USB-A, DisplayPort, HDMI, card readers, and Ethernet ports are good examples. You will need to tune the system to take optimal advantage of your hardware. Standardize and package these adjustments to ensure that solutions are reproducible. Here are some areas to tackle. Ensure suspend and resume work quickly and reliably. Use NVIDIA buffering to eliminate artifacts and identify and fix apps that can stall the process. Double the battery life with power profiles that strategically disable hungry power processes but aren't missed in mobile mode, like disk snapshots or keyboard LEDs. Pre-configure popular peripherals like Logitech keyboards, mice, and trackballs.
Well, alrighty, Eric. Thank you. Let's bring that back over here, and we can now talk about third-party repositories and why their setup is important or indeed critical in a lot of cases. So first, let's talk about what a third-party repository is. It's effectively a server that a vendor like Amazon or Google sets up, and that server sends us their software that runs on our computer. We say we want to coordinate those repositories because we want to make sure that we're using the official servers, that we have the right keys for those servers, and that we're getting the right software for the version of the distribution that we're using. Commercial software vendors typically only support LTS. So do yourself a favor and stay on LTS. Well, next up, let's talk about best-in-class apps. We suggest you identify best-in-class apps before anyone invests too much time into any one option. And you should keep records about why these apps were selected. Good criteria include fit for a particular task you're looking to accomplish, the capability in general of the app, its popularity, its support, its stability, its usability, and its documentation. There are certain apps out there that we might call super apps, and these are apps that have taken on an ecosystem of their own, and there are vast repositories of documentation and how-to videos that can get you through pretty much any situation. I consider LibreOffice or GIMP or even KDN Live or Blender to be super apps. We do suggest that you share your list with a web page or a spreadsheet document. And remember that any list should be a living document that's frequently updated. If you work with GPU compute, you know how hard and confusing setting up the libraries can be. Do this once and create a package to maintain it moving forward. That's our advice. You will need to actively manage the package selections to properly support GPU libraries alongside deep learning libraries. I'm not trying to be purposely vague, but this is a very short presentation, and I can't go into the detail without blowing our time limit. Another interesting angle of this is that sometimes it's only possible to install software using language-specific systems such as pip or npm. And this is typically true with software under rapid and active development, just like deep learning toolkits. So if you find yourself in this situation, you can't reproduce your system using a standard package in the normal fashion. However, you can create an installer app that can be managed through the normal package system, and that installer app will create a known state that you're looking to achieve. So if you look at our deep learning installer app that installs between 4 and 6 different deep learning frameworks, that embodies a whole bunch of information and a whole bunch of research, and that is managed through the package system. Let's talk about theming and optimizing apps. As we talked about before, we'd rather not add content to a welcome wizard or write a how-to instructing users on how they might optimize and theme their apps. Instead, we want these things to just work out of the box. This approach is best for everyone, and we do it for dozens of apps. For example, we should be able to install the Brave browser, and when we open it, we should find the theme matches the system theme, and the About GPU page is pre-configured for optimal GPU use. We suggest you too focus on just works before exploring use of wizards or documentation. All right, let's talk about guided solutions. At least that's what it says up there, there we go, up there in the slide. So first, what's a guided solution? Well, a guided solution is simply a how-to document, but we don't call them how-to documents because that's an insult to guided solutions, and I'll explain why. When you find a how-to guide on the web, which we've probably all done numerous times, even in the last week, if not month, oftentimes it's not the first how-to guide we're going to use, and it's not the last to help resolve an issue. And that's because how-to guides suffer from these problems. They're not for our hardware. They're not for our circumstance. They're too old, or they're incomplete for one reason or another. Some how-to guides exist on forums, and the joy of reading forums is that oftentimes the forum discussion will start with a problem, and then there'll be a bunch of bad suggestions to start out with, and then it'll move towards a solution. And the fun part is going out there and picking out, oh, this part of this response is correct, but this part isn't. And this part looks correct over here, but this guy is wrong, and this gal is right. And so you've got all these data points to pick from, and it's kind of rolling the bones here on getting things right. So that's the reason why we coined the term guided solution, because all those variables are removed. And when you create documents for yourself and your team, you should try to do the same, because it's just so much more valuable and such a more rewarding experience to have a solution that's effective immediately. So there you have it. We hope this quick overview on curating systems got you thinking. The steps we discussed aren't unusual or unique to Linux, although some steps may require more effort, while others, such as ensuring compatibility with deployment environments, are pretty much eliminated. We'd be happy to answer any questions in the few minutes we have remaining. Thank you.
Hey everyone, I am Sarah Fakhoury. I'm currently a doctoral candidate at Washington State University. My research is at the intersection of cognitive neuroscience and software engineering, and I'm super excited to be here today. And I'm going to talk a little bit about how software engineering researchers are using neural imaging to study the cognitive impact of code. And I have a few actionable tips to reduce the cognitive burden of the code that you write. So I think every developer can relate to, at some point, feeling incredibly frustrated reading someone else's code, right? It's kind of like weeding through a jungle. And once the jungle clears and you start to understand a little bit more, you start questioning decisions made by the original author. Like, why did they use this structure? And where does this bridge possibly lead? And then you see a sign that says, this is a bridge, and that's seemingly useless documentation. And trying to understand complex or inefficient code can be cognitively exhausting. So you end up wondering, like, what was my colleague thinking when they were writing this code? And even worse, it can be past you from like a week ago. This is your own code that you're reading and you have no clue what's going on. And, you know, we're all trying to look for ways to grow as developers. So I think it's interesting to look into the question, how can we write code that's easier to understand? And the first place to start in order to answer that question and avoid, you know, having this jungle of code for our future selves and our team members to look through, is to really have a fundamental understanding about what makes code difficult to comprehend in the first place. And there are some obvious things, right? The first thing that comes to my mind is, well, code that's not formatted well, that makes things hard to read. So these are two snippets. They're doing exactly the same thing. One just has really bad formatting. And so, of course, it's much harder to read. But does that mean that it's difficult to understand? And I don't think necessarily that it does, right? Once you are able to read the code, you realize that, okay, this snippet is pretty straightforward. I can reason about what it's trying to do fairly easily. So it's not difficult to understand. It just has poor readability. Then on the other hand, you have something with great readability, right? It's just one line of code. It's easy to get through, but this example is difficult to parse and understand because there are many different conditions to keep track of. They're nested, right? But shorter and more concise code doesn't always mean that it's easier to understand, right? So here are two snippets that are doing exactly the same thing again, but the one on the top doesn't have any informative variable names, and it's using magic numbers like 12.5 and 150, whereas the version on the bottom defines what those magic numbers are, and it has really informative variable names. So when you're creating a mental model and executing this code mentally, instead of saying, okay, what is I, what was J again? What is temp value doing here? You can say like, okay, we're looping through all of the rows, all of the columns of this matrix, and then we're multiplying by the pixel normalization factor instead of just 12.5. So it definitely makes it easier to comprehend and understand what's going on, even though the snippet on the bottom is less concise and maybe a little bit longer. So how does our brain actually process code? What's going on in our brain when we're reading code? Well, we know that our brain is using multiple areas of the brain, right? It's not just one, but it's very heavy on working memory, right? We create these mental models of code using the syntax and the semantics, and then we mentally execute the code, and we store information like variable state, what loop we're on. We store all of that in our working memory. But when code becomes too complex and there's too much to hold in our working memory, the code becomes difficult to reason about and understand. There's only finite room in our working memory. It's not this infinite resource. So sometimes we have to go back and reread like, oh, what was I again, right? What was this variable state at this point in time? And this is defined as cognitive load, right? It's the total amount of mental effort being used in our working memory. And so when code becomes more difficult, we use more of our working memory and we increase our cognitive load. So if we want to write code that's easier to understand, it makes sense to study this from the perspective of cognitive load, right? And understanding when is code causing high cognitive load? And can we write code that is less cognitively taxing? And, you know, we have styled guides that are designed specifically for this purpose to make code easier to understand, right? And style guides are pretty binary. They'll say things like, do this and don't do this, right? Like use camel casing, don't use global variables. And, there's pages and pages of recommendations, but which are the most important practices? And what's the cognitive cost of each of those practices? What's the cognitive cost of using well-structured code, well-formatted code versus not? And researchers conduct experiments to get empirical evidence about the best ways to write code that's easy to understand, and that's how these practices come out. But we don't have any empirical evidence about how these practices affect cognitive load, right? And how could we do this? How can we start to identify the cognitive cost of different practices? And I think the most common way, and the way that researchers use right now, is to just ask developers, right? You conduct a controlled experiment, isolate a feature that you want to study, and then you just ask, was this code snippet difficult to understand? And so we call these self-reported measures, right? Where the developers are telling us how difficult something is, or we're inferring it from a comprehension summary, right? But there are some issues with the accuracy and authenticity of self-reported verification from surveys and think aloud protocols, right? For example, participants in a study might have personal biases that cause them to underestimate their ability, so they might inaccurately rate task difficulty. And here's an example. I'm a researcher and I want to compare how difficult a task is across all of my participants. So I'll use something like a Likert scale. On a scale of 1 to 5, where 1 is super easy, 5 is very difficult, and it's a standardized scale and it allows me to compare across participants. So in theory, it sounds great, but this might be one of the thought processes of a participant that causes them to incorrectly rate task difficulty. So they might think that, oh, at first this task was super hard, but then I realized that that's my fault. I completely misunderstood what was going on and I made a mistake. So I won't factor that into my rating scale, and I'll rate it as a 1 out of 5. It's super easy because that's on me. That's not the objective rating of the snippet. And so you can see how that's very terrible for researchers, right? As a researcher, I want to know if you made a mistake while trying to understand something, because chances are many other people will as well. And that's a huge factor in probably the aspect that I'm studying, but how to increase comprehension of a piece of code. How can we avoid those mistakes, right? So self-reported measures are, prone to biases. They can be misleading, and they're not perfect. So are there more objective measures out there? How can we measure the cognitive load caused by code in another way? So we can learn a lot from other researchers who are studying working memory in different domains, like in cognitive neuroscience, right? And they're using neural imaging to quantify cognitive load for different tasks. And it all boils down to this concept that different areas of the brain that are active have higher demands for oxygenated blood. So the harder a certain area of your brain is working, the more oxygenated blood rushes to that area. So if we can measure the amount of oxygenated blood in the areas of the brain associated with working memory, then we can quantify cognitive load, right? And if we can measure cognitive load on developers that are reading code, then we can quantify the effect of that code on the working memory areas of the brain. And this is exactly what we do in our research. We use a brain imaging technique called functional near-infrared spectroscopy, or FNIR for short. And this is exactly what it does. It measures the amount of oxygenated and deoxygenated hemoglobin, or blood, using near-infrared light. And we measure it over the prefrontal cortex. And that includes an area of the brain that is associated with problem solving and working memory. And the great thing about FNIR is that it's used in a wide variety of working memory research. And it allows replication of real working environments. So look at that picture. It's basically just a headband. And it's not too uncomfortable compared to other brain imaging techniques like MRI, for example. And it allows us to put this brain imaging technique on developers while they're at their own desks using their own computers, programming in an IDE. And the best part is that it can be paired with eye tracking. And so if we can combine information about the cognitive load that a developer is experiencing at any given moment in time, and map that to specific identifiers in the source code using an eye tracker, for example, then we can obtain this super interesting information about specific identifiers in the source code and how hard someone's brain is working, right? And how much cognitive load they're experiencing while they're reading that area of the code. And so this is what eye tracking data would look like, right? We're just tracking where a participant is looking in the source code. And in this example, they're typing a line of code, and we can see that they're looking where they're typing, and they're looking a little bit at their surrounding code as well. And then we can pair that with cognitive load data. So you can see at the top, we have a graph showing the amount of oxygenated and deoxygenated hemoglobin in the brain. And we're able to map that cognitive load data to specific areas in the code using the eye tracking data. And then the colors of this heat map that you're seeing are corresponding to the amount of cognitive load. So dark red means high cognitive load, and blue means light. And so now we can create these more objective models of cognitive processes and understand how different constructs are affecting cognitive load. So we have this really great framework. There's this really famous quote by Phil Carlton. There are only two hard things in computer science: cache invalidation and naming things. And I love this quote so much for many reasons. But now that we have a more objective framework to model cognitive processes and cognitive load, the first thing we wanted to study is how important is good quality documentation, picking the right variable names? And what's the cognitive cost of not doing that? And the literature tells us that source code lexicon is incredibly important to program comprehension, right? It's not even debated. So can we see the impact of source code lexicon on cognitive load and developers' productivity? So we ran an experiment with 25 developers. We set up the FNIR and the eye tracker. We hooked everyone up, and we asked them to find a bug in a source code snippet. And we designed the task where there's two snippets, they're exactly identical, they have the same code, the same bug. The only difference between the two snippets is that one had poor quality lexicon. So the code had poorly named identifiers, outdated comments, incorrect comments, and the poor quality lexicon, the issues that we injected into those snippets were not out of the normal. They were snippets and issues that are widely found in our code bases. And they're actually called linguistic anti-patterns. And they're defined in the literature as poor practices that cause inconsistencies between naming, documentation, and then the actual implementation of the software. And so essentially what linguistic anti-patterns do is they cause inconsistencies in the mental models that we build when trying to understand a piece of code. They're misleading and they're confusing. One example is this set method that's returning something. So if you were to see the API call just set breadth without seeing the method definition, you would think that it's just setting the breadth, right? You wouldn't necessarily expect it to return anything because that's the convention. Set methods should not be returning anything. But in the implementation, it's creating a new object and returning it. So there's this inconsistency between what you're expecting the method to do and what it's actually doing. Another example is this get method. This get method is great. It's doing what it's supposed to do, right? It's just returning a value. But from the method name, again, you're expecting get expansion. So you're expecting to return an object called expansion, and that's a singular object. But instead, the return type is a list. So you're getting a collection of objects. So again, there's this inconsistency between what you think will be returned and what is actually being returned. Inconsistencies and linguistic anti-patterns can also exist in the documentation. So if you read this summary comment, it's describing what the method is doing, and it's saying that it's trying to determine if the back button is enabled. But then if you read through the code, you realize they're using is forward enabled, navigate forward, right? Is navigate forward enabled? And so there's this discrepancy. Are we talking about the forward button or the back button? I don't know. And should I trust the comment or should I trust the implementation of the code? So there's this bug in my mental model now. And linguistic anti-patterns can also affect variables. So is reached. If you see that variable being used, it's asking a question, the response should be yes or no, maybe a Boolean, right? But instead, it's an integer array. So what is this variable holding? I have no clue. And the same goes for stats. Okay, I'm expecting a collection of stats, maybe statistics, but the type is Boolean and it's set to true. So stats are true. It's a little bit confusing, right? So we wanted to study what happens if these very common code smells are inside of a bug localization task, and how do these affect the cognitive load of developers compared to the control snippet? So we compared our control group to the group that had the poor lexicon, and it turns out that linguistic anti-patterns are misleading participants, and they're hurting productivity in very concrete ways. So the first is correctness. 65% of the participants could find the bug, but that's much lower compared to the 77% of the participants in the control task. And keep in mind, that's the same exact snippet, the same exact bug. The only difference is the variable names changed and the comments changed. And it took them almost twice as long to find the same bug. So almost 6 minutes versus 3 minutes for our control group. So that's a huge impact on efficiency and productivity. And most importantly, there was very obvious and significant increased cognitive load in our group that saw the poor lexicon. They had much more confusion to work through because of the linguistic anti-pattern, and their working memory was much more taxed than the people in the control group. And so these are no longer opinions or anecdotal advice in style guides, right? We have empirical evidence that our source code, comments, variable names, our documentation need to be kept up to date, and they need to be consistent. And I only went over a few examples of linguistic anti-patterns, but there's a whole catalog, and I encourage anyone who is interested to go take a look at these. So if you remember our first example that we looked at the beginning of the talk, we had some obvious examples about what makes code hard to read and hard to understand, but we really wanted to use our neural imaging framework to see if we have empirical evidence that something like code structure actually impacts cognitive load. And so that's the next thing that we studied. And we set up the task exactly the same. So we have two identical pieces of code. They're doing the same exact thing, right? They have the same exact bug. The only difference is that one now has poor structure. And for the purposes of our experiment, poor structure meant that we changed the formatting, we changed the depth of nesting, we added some variables, all while keeping the same task and bug as the control snippet. And what we found that now even less people could find the bug compared to the control group, right? 55% compared to 77%. So structure really impacted their ability to correctly find a bug. And it also slowed them down. It took on average 4 minutes versus 3 minutes for the control. But what's interesting is that they were faster than the group who had poor lexicon. And participants were very frustrated when reading poorly formatted code with poor structure, and they were talking about it a lot too, right? They were like, oh, this code is terrible, I don't even want to read it, right? But what's interesting is that even though it was frustrated, it wasn't taxing on their working memory from what we measured, right? It didn't have a significant impact on their cognitive load. So they were difficult in a different way, right? And there's different aspects of what makes code complex. And poor lexicon created inconsistencies in the mental model, but poor structure just made the code hard to read and wasn't necessarily taxing on working memory. So one of the biggest keys to becoming a more productive developer is writing code that's easier for you and your peers to navigate. And we saw that there's several different factors that make code difficult to understand and difficult to navigate. So code might be easy to read, but hard to understand, or hard to read and easy to understand. And poor practices have different costs, right? We saw that some are more taxing on working memory resources, like linguistic anti-patterns, whereas some greatly impact readability, but don't necessarily tax cognitive load. And what's nice about neural imaging is that now we can start getting a deeper understanding of the different types of complexity that can arise in code. And we can become better programmers with this information. And one actionable tip that we saw today was to make sure that our comments and variable names are semantically consistent with their usage by avoiding linguistic anti-patterns. And we saw that code that has high cognitive load can slow you down and have cascading effects on productivity for future you and your team, right? Our naming and documentation choices now have tangible impact on our readers' brains, and we have empirical evidence for this. As researchers, we really strive to produce research that's applicable to developers' daily work and improves your workflow. And so I'm really interested to know what you guys want to see studied next. How can we apply this framework? What features should we study? For example, some people are deeply invested and highly passionate about static versus dynamic typing. Another question I have is, what do future style guides look like? Are we going to have cognitive price tags next to each coding practice? And what does a programming language designed using neural imaging look like? Reach out to me on Discord or Twitter anytime, and I'm happy to discuss with you all.
Hi there, my name's Mark Winteringham, and welcome to my talk, Augment Your Testing with Web APIs. I want to talk about two things today. So first of all, I want to share with you an example of how I used web APIs to support my testing, specifically how I built a web API to help me test further, test faster, whilst working with a very large, complicated system. And then I want to talk a little bit, I want to take a sort of step back, and I want to talk about the patterns, the behaviors that happened, that if we are aware of them, if we observe them, then we can identify opportunities to potentially build APIs to support other testing activities, or maybe other tools as well. Let me begin by sort of telling a quick story about this web API I built. It was basically what I called a data dashboard by the end. I was working on a project for HMRC, which is part of the UK government, and HMRC are responsible for tax collection in the UK. There was this big digital transformation happening within the space, and I was working as part of a wider platform team in which we were sort of updating a lot of the services around HMRC. And the result of that was we had this massive microservice platform that was just growing and growing and growing. But the way everything was structured was we had teams that were focused on specific areas of this platform. So my team, we were responsible for somewhere between, I think, 10-ish microservices, maybe a little bit more, not quite sure. And we were responsible for services around sending notifications. Instead of sending letters out to say you need to file for tax, you need to pay your tax, you're due a refund, so it's not all bad things all the time. Instead of sending letters, we were going to send emails and notifications so that you could view all of this online. So yeah, we were responsible for the microservices that made up that part of the application, which was really interesting because the way that it was set up posed some challenges for the testing that I was doing. So rather than doing sort of a traditional push pattern where we would submit something in a form or something within the UI and then we'd push that data in and get some sort of results back, It worked the other way around. What we had was this bucket that sort of sat at the back of our system, so to speak. And what would happen is some other system built by some other company would do all of the sort of tax calculations and the processing of like when to send these letters or when to send these notifications out, and they would drop it in this bucket. And then what would happen is that each of our microservices were working on schedules. So the first microservice would wake up and it would look in this bucket and it would pull some information into the API. It would process it, manipulate the data, maybe add some extra fields to it or update some other bits and pieces, and then it would stop. Then the next API or the next few APIs down the line, they would wake up and they would pull the data from that first API into their sort of services and then manipulate the data again. So the idea being is that this data started in the bucket in the back end and it would bubble up to the surface, and that's where the notifications, that's where the message details came from. A very interesting architecture to be testing. We were lucky enough that we could deploy this sort of stuff locally. So I would have the environment, our part of the environment set up along with other supporting APIs. And then I would do exploratory testing and I would come up with hypotheses, questions, ideas around ways in which, like, what if this data was in this way? What if this information was added? And I would put them in the buckets, and then I would have to sit there and wait for things to sort of appear in my UI. And that was pretty slow going. It took me a long time to do my testing. And what made matters worse was that if something failed, it would fail in one of those APIs. So I wouldn't see anything in the UI. So I would have to open up like 9 instances of, or like 9 terminal windows and connect to each of these databases and run queries against the databases in each of these microservices to find out which one had the problem. Very slow going, very frustrating. And then, I'd find out what the problem is, have a conversation, maybe write out some issues, some bug reports about it, and then I'd start again. Yeah, I was getting quite frustrated and it was just taking me a long time to get through all these different steps. So one thing I realized was that the databases that we were using were called MongoDB. And at that point, I don't think this exists now, but at that point, MongoDBs had an HTTP interface, and we could turn them on locally. What I did was I turned them on, and I realized I could actually make my queries via HTTP requests. Rather than going in, opening a terminal window, and writing everything in, I could just do one request. So I saved that request as a bookmark. So I basically had a bunch of bookmarks sitting on my browser so that I'd run some testing, and if something failed, I could just click a link and go through them. It started to speed me up. I didn't have to go through all those complex steps to find that data. So that was really cool. But I started realizing that it was still a bit frustrating because I'd have to have 9 tabs open. I'd still be cross-referencing the data and everything would get a bit messy, and I always have too many tabs open anyway. So I got to this idea. I was like, well, it'd be really good if I could get all this data into one view, if I could just look at it all in one go. So I was like, well, how do I get all this data from all these different requests together? So I started experimenting with some JavaScript, and it was a bit messy. And then I thought, well, what if I just built a very, very thin API that just made these requests for me? At the time, I was playing around with Node and with JavaScript. So I set myself a little project where I built this API. And what it would do is it would go through. So I had one endpoint. I would make a request to that endpoint, and then that would go off and make all these calls to all these different APIs and query the databases and get all the information back, and then it would collate it all into one big JSON object and send it to me. Now I was at this point where I could actually see everything. So if something failed, I could immediately be going, right, make a call to that API. What information do I get back? Which is very cool. And again, speeding me up a little bit further. The analyzing side of things became a bit easier. And then I made this sort of final leap where I was looking at this data and I was a bit like, oh, this is interesting because this data, if I visualized it in some way, so I've got all these different APIs these databases and these APIs that I'm calling distinct requests on. What if I just did a little bit of styling and put them into nice little boxes? So just added just a very sort of a thin layer of UI onto it. And it was literally sort of create boxes, just little tables on a web page, and then I just added a little bit of jQuery at the time to just make the request to the API for me, and then inject the data into each of these boxes. And what was really interesting was by making that sort of visual leap, I started seeing that actually what I had was a model of the system that I was testing. I had a visual representation of all these APIs and how they spoke to each other. Each of these boxes had names that sort of determined which API was what. I arranged them in the flow of these APIs and how they would work to let the information bubble up to the surface. And then finally, I just put a 5-second refresh on the page. So every 5 seconds, this data dashboard would start updating. And what was really interesting was that not only had it, like by this point, I've really sped up in my testing because I just didn't have to connect to all these databases anymore. I didn't have all the terminal windows to manage. I could just look at this screen. But it started affecting the different ideas I came up with because I could see the application in a visual manner. I could be like, well, what if I go down this route? What if I go down that route? Oh, I tested this idea out and I can see it's frozen somewhere in the middle. I can see that API's not been running for a while. I had a visual cue to help speed me up. I started at this position of I've got a load of testing to do and it's proving to be slow. But what I ended up with was with a tool that actually not only sped up and increased and just helped me with my testing, but it kind of changed it. It kind of made me think about it in a different way. And what was also really interesting was after I built this tool, I could see that others in the team were expressing interest in it. They wanted to use it as well. And they started using it for debugging issues. So it became sort of a utility to the main application. And as that application progressed, we would make changes to this dashboard. Obviously, there could be other tools that could have been used to do this work for me. And I'm not disputing that. What I think is really interesting is the journey. The journey I took to identify this opportunity to build an API. And that's I want to take a step back and talk about opportunities within exploratory testing or within other testing activities, triggers that make us think of ways in which we could potentially use tools like web APIs. So yeah, taking a step back, regardless of what you want to build, I think it's important to reflect on when to sort of identify those opportunities. So I run a training course with my colleague Richard Bradshaw called Automation in Testing, and we talk about the idea of automation opportunities, different actions, different behaviors that we can reflect on to identify what automation we want to do when. So there's 6 of them: repetition, shadowing, OGs, time, steps, and boredom. So starting with the repetition one, I think this is really interesting because this is where I think a lot of ideas of automation come from, through the form of repetition. We want to be able to replicate testing quickly with a tool. And that comes with its own inherent problems that we're not going to get into in this talk. But it is certainly a good cue. So if you find yourself repeating to do things, so for me personally, I found myself repeating the act of opening these terminal windows up and connecting to all these databases and doing these queries. The fact that I was repeating those things, that became sort of a highlight to me. I was like, hang on, I don't want to do this anymore. I want to do something else. So yeah, noticing when you're repeating yourself, doing the same actions in your testing, that could be an opportunity to use some sort of tools to help speed that repetition up so that you can get to the fun stuff in testing. And then there's shadowing. So shadowing is a really good way to actually observe some of these other behaviors. I think sometimes when we are testing, or when we're just doing various activities and we're stuck in that repetitive loop, we're so sort of concentrated on the act of doing something that we don't take that step back to go, hang on, I've just done that same thing 20 times. Maybe I should do it somehow differently. So with shadowing, you have someone working with you. So pairing is a really good opportunity for this. And I know a lot of discussion, a lot of talk is done around sort of pairing in a programming sense, but also pairing in a testing sense is really valuable as well. So by observing or being observed, you can identify some of these other patterns, these other behaviors. And then OGs. So some of these opportunities are things that we've done multiple times, or behaviors that we sort of display to others, but sometimes they're feelings. So that feeling of, oh geez, not this again, that frustration as well, that sort of almost like, I can imagine rolling your eyes as you're sort of thinking, oh God, I've got to do this. I've got to do this again. Oh, I don't want to do this again. So that feeling can be a trigger. If you're feeling frustrated, then maybe there's some sort of opportunity there. Maybe you're doing something fairly algorithmic that could be replaced with a tool. And to be clear as well, like these things I'm talking about, I'm not saying replace the whole thing with automation, but this sort of mixture of both. So I'm using tools to help me get a certain way down the path before I pick it up. And then time as well. So if we find ourselves just wasting time, a good example I have of this is I worked on a project where just getting the environment set up just took a long old time. So identifying that as a time suck, realizing that was all of that time that I spent setting up and reinitializing the environment could have been doing other testing or doing other activities. So we started looking into sort of infrastructure tools as well. Yeah, using time as a factor as well. If you feel like something's a waste of time, then maybe automation is a space for you. And then steps. So we talked briefly just then about with the OGs one about this idea of using automation to get yourself a certain step of the way before taking over the testing, and that's what steps is used for. Talking about that API example about creating data for me, the reason why I created that API was because I was testing an application that required lots of fresh data to be created, that I would then trigger different things to happen to change that data. So I needed just a load of vanilla data in different formats. So rather than going through the UI and clicking things manually and stuff like that, I actually created this API to just make all of the requests for me and do the work for me. So I could just call post create me 20 news pieces and it would create them with some random data. Now, it's something just to add to this as well with that example, some of you might be thinking, well, why don't you just create it in the database? Or, why don't you start up the database or start up the application with a load of fresh data? And yes, that is possible, but sometimes the testability of a product, sometimes the way it's architected, sometimes the way it's locked down prevents us from doing those things. Sometimes with these opportunities, you're thinking of ways to sort of compromise. By building that API that made that data for me, it was quicker and easier than trying to sort of have a whole conversation with the ops department to give me access to the database and go through security policies and that sort of thing. I was doing everything within the spirit of all of the security policies and that sort of thing. And then finally, the one I think that's quite important is boredom. For me, testing should be fun. It should be exciting. It should be engaging. You're being creative. You're thinking of ideas. You're engaged with the subject matter that you're testing. If you're bored, if you're disengaged, then I don't really think you're testing anymore. I don't think that you're really receiving or any information. You're not observing things. You're too focused on the task at hand. So boredom can be a massive trigger for you. Those are my 6 examples: repetition, shadowing, OGs, time, steps, and boredom. To wrap up, what I've shared today is, first of all, an example of how to use APIs in a way that's not necessarily for like production systems, but by identifying opportunities, things that I was doing in my testing to build an API for. And it may be that either you're the person doing the testing or you're in a team where testing is happening. If you're doing the testing, then It may be that you need to have a conversation. You might identify an opportunity and want to have a conversation with someone else in your team to help you build this API. But if you're someone who builds things, is a developer, then maybe sit down with other team members and talk to them. Like, what are your frustrations? What's slowing you down in your testing? How can we maybe build some tools to help speed that up? And then finally, the triggers. There are 6 different ways in which we can sort of reflect on what we're doing to help find automation opportunities. That was my talk. I hope you enjoyed it. If you'd like to find out a little bit more about me, as I said, my name's Mark Winteringham, and I've written the book Testing Web APIs, which will be coming out soon. You can catch me on Twitter at 2BitTester. I'm the COO of Ministry of Testing, so if you want to talk about anything testing related or anything going on in the testing community, please get in touch at mark@ministryoftesting.com. All that's left for me to say is thank you to Manning for letting me share this story, and hope to speak to you all soon.
Hi everyone, my name is Brian Rinaldi, and I'm here to talk to you about 3 productivity tips for the Jamstack. So some of you may be thinking to yourself, well, what the heck is the Jamstack anyway? I'm going to give you a brief overview. So the Jamstack is more of a methodology or architecture than it is a real stack. It emphasizes static first. So that means you pre-render most of the pages and content of your site. That's using a static site generator to take things like Markdown and templates and API calls and pull all that together to generate static HTML, CSS, and JavaScript that is pushed up to a CDN. But that doesn't mean it has to be static. You can leverage APIs both at build time and at runtime to have that dynamic content and interaction. So you can still have things like authentication and search and all the things you'd expect from a modern application. You can still get that from a Jamstack application. I do want to leave you with some resources though, so you can learn more about Jamstack, because that's a really, really quick overview. Let me go through a few of those. First of all is jamstack.org. This is actually run by Netlify, who came up with the term Jamstack in the first place. And it covers a lot of like why you'd want to use Jamstack, what Jamstack's all about, a glossary of terms. It gives you like links to headless CMSs and static site generators, and helps you filter through and choose the tools you want to use. There's also links to the community. There's a great community Slack that they run where you can meet other members of the Jamstack community. So if you have further questions, you can ask them. This article by Snipcart, everything you need to know to get started with the Jamstack, is a really good place to start as well. They update this every year to make sure it's up to date. Of course, I'm going to recommend that you check out the Jamstack book, which I am co-writing with my friend Raymond Camden. We've got most of the book out via Manning Early Access Program, so you can get a copy right now, and most of the chapters are already there. We try and give a good overview of all the tools and approaches that you can take to building sites with the Jamstack, with some common examples of like things like documentation sites, e-commerce sites, and so on. Now that we've kind of gotten what the Jamstack is out of the way, I just want to kind of introduce myself, since I didn't. I'm a developer advocate at StepZen. I also created a site named cfe.dev. This is a great resource if you're looking for educational stuff for developers. We cover a variety of topics. So there's lots of live meetups and video recordings on a variety of educational topics. So please check that out. As I mentioned, I'm co-author of the Jamstack book, and I've been doing Jamstack stuff since 2013, which is in Jamstack time, very, very long time. As I mentioned, I work at StepZen. If you're interested in Jamstack, we're building a great tool that will be really useful for you. It allows you to pull in multiple data sources like MySQL databases, Postgres databases, REST APIs, and pull all of those together into a single consolidated GraphQL API. This is really, really useful for both Jamstack apps and really any application. You can see the URL to request an invite there, so please do. Now, enough about me. Let's get to my tips. My first tip is going to be Netlify Dev. So Netlify Dev is a tool that's built into the Netlify CLI. And it really speeds up my productivity when I'm building Jamstack applications. Now, there are, obviously, this is going to only work with Netlify, but there are a lot of other options, like you have Vercel, you have Azure Static Web Apps, you have Cloudflare Pages. The list goes on. There's a lot of competition now in your options to deploy your Jamstack applications. I've used Netlify for years, so that's why I'm going to be talking about Netlify Dev. At its core, it really just is a way of launching your application and testing it locally. So instead of, say, if I was using Hugo, instead of doing Hugo Serve, I would do Netlify Dev. But it does a lot more than just replace your command for launching. So let me show you one example here. This is my cfe.dev site. It's built with Hugo. So first of all, you'll see that I have a command here. I've created a Netlify toml, and I've changed the build command for Netlify Dev. So by default, Netlify Dev will figure out what kind of static site generator I'm using, and it will automatically launch it for me, which is really great. But again, I've only then just replaced one command with another. But in this case, I need to use a special flag to build this site. The -- build future, which says that I actually want it to build pages that are future dated, which is great for like an event site like mine. But I don't. Instead of having to type Hugo serve -- build future every time, I still only do Netlify Dev. Now that already is helping me, but then it does a number of other things that are really important. So let me show you this. First, I'm going to go into my project. And then I'm going to run Netlify Dev. And you'll see in a moment, it's going to launch my site running locally. Okay, there's my site running locally. But that's really cool. Again, it used that Hugo serve -- build future so that you see pages that are future dated. Great. But what else did it do? As you can see here, it injected a bunch of environment variables. These are all to run Algolia, which runs my search in this particular instance. And those environment variables actually live on my Netlify site. So instead of having to maintain the environment variables in Netlify and then my environment variables in a local .env file, I'm able to actually just have those env variables injected into my application and available to my application when it builds and when it runs. So that is hugely useful. It gives you one place to maintain all of that stuff. But it's also doing something else. This site actually runs with a number of different functions. Netlify functions are basically like serverless functions, and we'll talk a little bit more about this and how you can deploy them with your application and things like that. But it runs a function server here that's listening on a different port. This allows me to test my site locally and test my functions locally and have the two communicate with each other as if it was running live on Netlify. And let me show you another quick example. Okay, this site is very simple. It's really a demo showing how I can pull MySQL data into a Hugo site. But what it's doing here, first of all, again, it's injecting all of these build settings pulled from Netlify here, and I don't have any functions on this one, but I'm going to actually open up the code for this here. Okay, what I've done is I've customized using Netlify toml. I've told it instead of running Hugo serve, run npm run dev, and then I can use my package.json to do a little bit more. In this case, what I'm doing is I say I want to run node, and I run this script here, and then do Hugo serve. So that script is going to pull content from an external MySQL database, write it out to the way Hugo expects to get it, and then run Hugo serve. But I'm able to kind of wrap all that up very simply so that all I have to do is run Netlify dev because I can customize the command that it runs. And because it does a lot of the work ahead of time, this script actually depends on the environment variables that it pulls down from Netlify. So again, you get all of these things built in just when you run Netlify dev. It's gonna run a command that I can specify. It's gonna pull environment variables from Netlify and any of the other information that Netlify has. It's gonna run a function server for me to test functions locally. And it's gonna spin all this up so that I can run this and live edit and see my changes as I work. Okay, let me get to my second tip, which is starters. And you may be like, oh, every library and every tool generally includes some kind of starters. What's so special about that? But the Jamstack community has hundreds, if not thousands, of starters that cover a wide range of tools and resources and just about anything you can connect to. And they're all really well done in a way that gets you a long way towards a complete application. So oftentimes you can use a starter and get everything, all the connections you need and all the code you need. And all you need to do is some customization and maybe some design, and you can launch a project in under an hour. Let's look at Next.js. Next.js is one of my favorite frameworks for building Jamstack sites. It can do both Jamstack sites, so it can serve as a static site generator, and it can do SSR, which is server-side rendered sites, or it can do a combination of the two, which makes it really, really interesting and really unique. It's React-based, but even if you don't know React, it's actually relatively easy to learn because it simplifies a lot of things about React. At least that's my opinion. But it has a great list of starters here. So if you look at this, go to their GitHub library and you go to examples, all of these are starters for using Next.js. So let's say if I wanted to use, let's see, Tailwind CSS, which is really popular. They have a couple of examples with Tailwind here using Tailwind CSS. So I could go and let me create a little project here. So I'm going to go up here. I'm going to create project name Tailwind Next. Tailwind Next. Okay. And then what I'm going to do is I'm going to use their Create Next app. So I'm going to go Create Next app. I'm going to create it right in here, and I'm going to I'm going to use -- example, and the example here was with Tailwind CSS. So it's going to create my project for me. It's going to pull in all the assets I need to be able to use Tailwind CSS with Next.js, and then I can start right out the box with that code integrated. As I'm not going to wait for that here because it's going to take a little bit to run and deploy, but as you can see, there are hundreds of examples using Next.js. Gatsby is another React-based framework for the Jamstack. And as you can see, they have hundreds of starters as well, using just about anything you could want. You can even filter it. So if I want to use Kentico content, for example, I can click here, and here are ones that use Kentico content. There's a ton of them here. They give you a great head start on building any kind of application that you want. There's all different categories of applications, all different categories of connections, and so on. You can also, if you're going to use, like, say, a headless CMS, a lot of these headless CMSs actually include starters that allow you to get started with them using static site generators to deploy Jamstack sites. Agility has a bunch of them. This one is one of them using Eleventy. And this will get you a starter blog that actually is built with Eleventy but connected to Agility CMS as a headless CMS, and that connection's already there. I'm only using Agility as an example, but pretty much if you use any of the Sanity or Contentful or whatever, they have examples like this that'll help you get that head start to building the application with those connections built in. But the final one I want to show you is something called StackBit. StackBit is a tool for creating and generating Jamstack sites, and it gives you a great head start. So let me create a new project here. As you can see, they give you a bunch of different templates based on different types of sites. You've got documentation sites, e-commerce sites. I'm going to do this SAS software as a service theme here. You can then click that, and I can choose a different static site generator. So I can choose between Gatsby, Hugo, Jekyll, or Next. Let's just go ahead and use Next again. I can choose what headless CMS I want to use. So Sandy, Contentful, or Git-based CMS if I want to use some of their more advanced features, or I can even choose some of these others as well. I'm going to go ahead and use Git, which stores the content in my Git repository. I'm already connected to my GitHub account here, so I can just click Create Site. And what this is doing is it's actually going out. It is creating the site for me with that template, using the static site generator that I chose, connected to the headless CMS that I chose, pushing that code to GitHub for me. So it's in my own GitHub repository. I don't have to use StackBit services after that fact. They offer some inline editing services, which you'll see when this pops up live in a moment. But I don't have to use them. I'm not tied to StackBit in any way. The code is in my Git repository, and it's then deployed to my Netlify account. So it's already launched. So I have full ownership of everything. If I want to use StackBit services after that fact, I can, but I don't have to. And I've got the full code for a CMS-based Jamstack site. So you can click it here. Here's my site. It's going to load up their little editor thing in a moment here. And then I can actually click here and start editing. But if you want, I can go here. And well, the live site is still deploying, so I can't access the live site just yet, but there we go. All right, there's my live site. This is deployed to Netlify right now. So all of that I did in just a matter of minutes. So I can edit content here, or I can go into my Git repository and start editing the content via the code right away, customizing the layout and so on and so forth. So it's a great way to get started quickly in the Jamstack. Okay, let's get to my final tip here, and that is about serverless functions. So in almost any Jamstack application, you're going to need to do some kind of serverless functions for things like pulling content or managing authentication, or even just as a middleman to protect your API keys as you call an API that you have a protected API key for. So the good news is that pretty much any of the Jamstack deployment options offer functions. Netlify offers them, Versal offers them, Gatsby Cloud recently launched them as well. And what they do is it makes it really easy to build, test, and deploy the serverless functions that you need to run your application as you develop your Jamstack application locally. So let's take a look at how that works. I've got a little project here. It's a very simple project. This is a Hugo-based site, but I've created a simple function just for the sake of testing. To be able to deploy these in Netlify, all I have to do is create a folder named Netlify, and inside that folder, a folder named Functions, and then I put my JavaScript files. These will automatically, as I push them out to Netlify, Netlify will see them, and it will deploy them to AWS Lambda for you and make those available to your application. So I don't have to separately deploy things to AWS or Azure or wherever I need to deploy them to. I can deploy it as a single entity in my Jamstack application and have that pushed out to AWS for me. So in this case, I've created a very, very simple function that just returns some JSON. And I'm going to show you how this works in terms of local testing. As you might remember before, we learned that Netlify dev will automatically launch a functions folder. So let me run Netlify dev here, and that's going to actually go ahead and launch my site locally. Again, this is a very simple site as an example, but I want to test that function. So I'm going to call my local host, and I do /.netlify/functions, which is where the functions are living. And then the name of that function, if you saw, was just called fetch. So I'm going to go ahead and call that. And as you can see, it returned me data, but this is running locally. Obviously, I can, once I push this out to Netlify, I can then call it on Netlify. But it's great to be able to do this local testing of functions and then push those out and have that automatically deployed, and then you can use those functions in your deployed application. So let me show you how this works in Next.js as another example. In Next.js, I only have to put files in this page, my pages folder, which is kind of a default folder within Next.js, and then API, and anything I put in this API folder is now available as a function within my Next.js application. And if I deploy it to Vercel, who makes Next.js after all, or even to Netlify, it will automatically deploy these as serverless functions for me. So as you can see here, I'm calling the IP API, and I have a protected key. So this one is very, very simple function that only just serves as protecting my key and making that call to the IP API to get the user's IP address. But then I have other ones, as you can see here, that handle authentication using Auth0. So these are automatically deployed for me as part of my Next.js application. I don't have to do anything special other than just put them in the proper place and then deploy them. Okay, that's it for my tips and my time. If you need to contact me, if you have any questions, I'm at RemoteSynth on Twitter, or you can contact me at brian@stepsend.com. Thank you for your time, and thanks for listening.
Hello and welcome to my presentation. I'm super thrilled to be talking to you today about my favorite topic, and that is code reviews. My presentation is called From Bottleneck to Superpower, and it's a presentation about all the findings that I collected and the research results that I got from the last 10 or even more years of researching and working with teams on their code review practices. So I was for quite some time at Microsoft, and I was responsible for analyzing the code review processes at Microsoft and helping teams adopt better practices. We also owned the code review tool, the internal code review tool, CodeFlow at that time. And so this is how I came in contact with code reviews. And over the last years, I really got very fascinated by this topic, and I did more and more studies in that area, but also I worked more and more with teams, not only at Microsoft, but around the world on the code review practices. And today I'm going to share with you how you can actually improve your productivity while doing code reviews and what problems we actually have during code reviews with productivity. So I'm super thrilled to dive in with you in this really fascinating topic for me. And if you want to find more about my work, go to awesomecodereviews.com. But now let's go into that. If you look at code reviews, we see that code reviews offer a large variety of benefits. It starts from, well, you get more readable and more maintainable code, at least that's what we hope. You get improved solutions. You have an accident prevention mechanism with code review. Maybe you find bugs. There is tracing and tracking, which means that you can go back and really understand why a certain solution has been implemented in a certain way. There's also learning and mentoring happening in code reviews, and knowledge sharing. So plenty of reasons why people want to do code reviews. The question is that actually true? Are we setting out to do that, but do we actually get those benefits? And there are a couple of studies that actually show that we are getting those benefits out, right? There are studies on how code reviews correlate with a reduction of defects in post-release and pre-release software, so before we release it and after. We see that, for example, unreviewed code is 2 times more likely to introduce defects than reviewed code. There are also studies, this is a newer study done by Google or at Google, and it shows that 80% of the code reviews lead to code improvements. So yeah, right, that's good. And there are also findings around knowledge sharing, for example, by Rigby, which shows that code review really increases the knowledge of a team member about the code base, right? So more people are aware what's going on, more people have really knowledge about the code base. So all of these good things are really happening in code reviews. And so it's no surprise that when the pull request development model, which was introduced a couple of years ago, a lot of people actually hopped on the code review wagon, but I don't think it was extremely deliberate. So it was more than the source control versioning system suddenly had a feature that we are using, well, a pull request, right? And so while we are doing a pull request, instead of pushing the code over, somebody has to pull it in. And if these are two people, what are they naturally doing? They're looking at the code exactly because they don't want to pull something in that they have no idea what it is. Somehow it's their responsibility. And so in this change that happened here in the way how we're developing software, we saw that now suddenly people are adopting code reviews, right? And very often nowadays, code reviews are actually used synonymously with pull requests, even though it's not the same thing, right? A pull request is not a code review. You can have a code review without pull request and a pull request without code reviews. But very often it's used at the same time. And this is why we also see it as something similar, right? And so now all these companies having these code reviews and this pull request or pull-based development model, and they think, wow, we will be so happy, right? Our developers will just learn, they will strive, the code base will improve, and everything is great. Everything is great. But actually, that's not what happened, right? While I love code reviews, a lot of people don't love code reviews. While they are very widely adopted, they're also creating a lot of problems. And here are just a few of them. I've been working with so many teams, and it doesn't matter how serious they are about code reviews or how eager they are to make them work, still they are experiencing some of those pain points that I have listed here. And this is really just a small subset of all the pain points, but they're dealing with large reviews. What happens? Well, now it's difficult to review it. I don't understand the context here. They maybe have to wait for their code reviews to be done by the engineers. Maybe there is time pressure. Maybe there is low rewards or almost no rewards going on. Maybe you have a low feedback quality, performance pressure, social things like bullying, conflicts, feeling attacked. So all of that happens in code reviews. That's the brutal, honest truth. And so we have to weigh the benefits that we have with these pain points. The good news is that I've been working with a lot of teams over the years, and these pain points can actually be worked on. So you can remove those pain points and you can really get to a very, very beneficial practice where all of your engineers said, I never want to work in a team without code reviews anymore, right? So you can reduce the pain points if you're deliberately working on them, and you can increase the benefits. And so how do you have to do that? Well, you have to, first of all, not just accept that, well, there is a feature, we are using it, and now everything will work out of the box. Code reviews are actually a socio-technical engineering practice. This means that you have to have really good social skills and you have to have really good technical skills. And if we think back about, let's think about testing as an engineering practice. Who would assume that an engineer starts testing, automated test, writing automated test, integration tests, without ever having read anything or learned anything about testing? That's not something that we would assume. But code reviews are actually even more complex because you have the socio and technical engineering practice, right? So testing, you just have to deal with yourself and the code. Now you have to deal with your peers and the code. And then there's actually another layer which makes code reviews so painful and so difficult, and that's the organizational skills that you have to do. Because it's not only you writing the code, it's also somebody else reviewing the code. They have to have time, they have to be willing to look at that. And as an organization, we have to decide, how are we doing code reviews? What do we want to get out of code reviews, right? So we have the social side, we have the technical side, and we have the organizational skills. And it's actually, for me, really wild that people are not thinking about, how can we learn that? How can we train our engineers? How can we learn as a group, as an organization, as a team? And so this is why I think it's so important to think about code reviews and really how can we do them in a better way. So when I was working with teams and I saw this huge list of pain points that they are experiencing, I was thinking like, where's the root cause, right? So where should we start? Should we start working on, the social interactions? Should we start working on the low feedback quality? And when I analyzed it over and over again, I saw actually that there are two patterns, two main pain points that teams experience. And if you work on those two, you can actually improve a lot of the others, right? So they are all falling into place. And this is slow turnaround time and low code feedback quality, right? So either it takes really a lot of time or the quality is really, really low. And funnily, it's not either or, it's even that it can be combined, right? So some of the teams, and this is what I call the code review quadrant, and I would like to have people really reflect on that and think about where are we as a team in our code review practice, right? Do we have like high review speed, but low review quality, right? So a lot of looks good to me within a few hours or even minutes. Or do we have like maybe a high feedback quality, right? So thorough reviews, but it takes really a lot of time. Or are we even in a blocking state where we have like slow reviews and low feedback quality, right? So I'm getting looks good to me or something like that, or some nitpicking, but I have to wait a week for that. And I think where every team wants to be is in this power review area, right? In this quadrant place here, where you have thorough reviews, you get really good review feedback back, but the reviews are also delivered in a very timely manner. And so when I'm working with teams, I really try to get them into that place, right? So that we are improving the feedback quality and the review speed. Today, because this whole conference is about productivity, I will mostly talk about speed and how can we speed up. And so, but for that, I want to do some mental exercise with you, right? So a little bit of brainstorming. If I say I want to increase the review speed, what do you think happens with feedback quality? Can we increase both? Because that's what I'm actually promising in my code review workshops. Can we increase the speed and the feedback value at the same time? Or is this impossible? Maybe we think something like this happens. If we increase the speed, we actually decrease the feedback value. Well, I'm writing a code review book. Let's say I tell you, please review my first chapter. It has 30 pages and I give you 5 minutes. What will happen? What kind of feedback can you give me? Well, it's a very different kind of feedback than if I give you a whole day to review those 30 pages. And very similar, we see that in code reviews, that if you think about really this reviewer perspective, well, one person in front of their code review, if you're increasing the speed, you're decreasing the review value, right? Obviously, there's a certain point where it's okay, but if you don't have enough time, you cannot give a very quality, thorough review. And there are studies around this. This is a study from Cisco Systems, for example, where we see that the defect detection rate, right? So how many defects per 1,000 lines of code are people finding versus how many lines of code they have to review within an hour. And you see that around 200, it starts to drop, right? And so from this study, there's actually this guideline that you should have like 200 to 400 lines per code max. And nowadays, the suggestions are even lower, right? Less than 200 lines of code. It would be better having 100 lines of code. And so there's a correlation, some relationship between the speed and the value. I'm not going to go more deep into that, but you can actually increase both. And where's the easiest to do that is with the process speed, because reviewing, as I said, is not only an individual practice, it's a team practice. And so suddenly it's not only how long does that person take when they're in front of the review, looking through your code, right? Let's say you send them 400 lines of code. It doesn't really matter if they take an hour or 1.5. That's not the real cost that you have in code reviews. The real cost that you have is that that person needs to have time to look at the code review, and that could be 4 hours. And maybe there's another person even on the code review because you need 2 thumbs up. And so that person needs 6 hours until they can get to the code review. Maybe there is like a time zone difference or whatnot. And then it doesn't matter if one needs 45 minutes and the other an hour, right? So this is the smaller cost. The really expensive costs are the process costs around. And what I see over and over again, and there are many studies also around that, is that if you have like the process speed, if you increase that, you make that faster, more smooth, then you're increasing the feedback, the review value. And I want to give a small example for that. Let's just imagine that I'm sending you the same feedback today versus a week later. Even though it's the same feedback today, it will be more important, more valuable to you than if I send it to you in a week, right? And so this is just to summarize the problem that we are seeing. And this is a person that states the problem is that there can be a lot of lag between asking someone to review the PR and them actually doing it, or between addressing comments and them making another look, right? Worst of all, you never really know how long things will take. So it's hard to know whether you should switch gears for the rest of the day or not, right? So this is, I think, a good, very personal and very individual perspective on the problem. You can have obviously also an organizational perspective, but this is an individual perspective, and a lot of people, I think, feel these pain points. And so one rule of thumb, but really a good rule, is that if you're in the middle of a focused task, such as writing code, don't interrupt yourself to do a code review, right? So the worst that you can have is like some pull request reminders, code review reminders popping up while you're doing something very productive, while you're in a deep work phase, and then you're going to do a code review. That's actually a horrible practice, right? So we don't want that. And there are also a lot of studies. This is actually a study done by Microsoft around interruptions during developer time, right? People writing code. And we see that it increases task completion time, so it takes longer. It makes you make worse decisions. It leads to more errors, frustration, annoyance, and anxiety. So no, we don't want that. There are also other studies that show that even 2 seconds of interruptions cause a lot of more mistakes and a lot of delay. So what can we do instead of like hopping over to the code review? What can we do? Well, there are a couple of really best practices that we can extract out. This was a study that I've been doing at Microsoft, and we could really generalize a couple of those things where we say, independent of the practices of the teams, because code reviews at Microsoft are very diverse, right? Teams have different practices that they have. Those are common strategies that really are helpful to speed up the code review and improve the value. Well, first of all, self-review. So instead of sending code out, you do the review yourself. Maybe you have even a checklist there. You see the diffs. And probably you experienced that yourself, that you were writing a feature and you actually forgot that you did this and that and changed something over there as well. And only when you're creating a pull request, you suddenly see it again, right? That's also called the expert blind spot. You get very familiarized with your own code changes. So looking at that and really making sure this is high quality code, the highest quality code that I can produce before sending it to somebody else, right? So really small management cost here. Then having small reviews, and I will talk a little bit more about this, so important, coherent code changes that it really makes sense. I will talk about this as well. Context, write those code review descriptions. I know nobody does it, but there's plenty of research that also shows that it's really important. I've done one, and we saw that the effect is really tremendous. Training. It's so important that people know what to look for in code reviews, how to do a code reviews, that you have set up right rules, that people are not wasting time on deciding whether or not they should comment on that, and maybe they're arguing in code reviews about something, but really have a training and have some education around that people know what to expect and how to do that. Then run the tests first. You run the test first and then you send it for code reviews. Have automation in place. Whatever automation can do, people don't have to do, and that's 2 thumbs up. If I have more hands, I would have more hands up. Automation is really important. So it could be static analysis, linters, style checkers, and a lot of other things. So what you can automate, please automate it so that people don't have to do it. And then have the right tools around it, CI and CD, right? There could be risk assessment, and that goes a little bit back to training again, that people actually know what's the risk associated with this change. And depending on that, you actually assign the right reviewers. And then it's crystal clear guidelines and policies that really reflect your goals, because only then you're actually doing something very productive here. But there are other things also, and a lot of those things has to do who should be on the review, when should they do the review, right? How many reviewers and so on. And there are some strategies that you can actually have that are beneficial, like time blocks that you say, well, developers start actually the day or end the day with some code reviews. So it could be in the middle, depending on the time zones that you have also to serve, right? There could be rotations. A developer takes over a code review per day or per week, right? There could be behavioral mechanisms that you say, well, whenever you're sending out a code review, you're asking for a code review, you do one in return. And there are also algorithms that can help you, like round robin or load balancing algorithms and tools that help you to actually assign that automatically. But you have to be aware that your strategy here has to reflect your goals, right? Finding defects, improvements, awareness, mentoring and teaching, tracing and tracking, right? If I want to find defects, I definitely have to have a person that's more experienced. And the best is a person that has seen this code before. We have seen that in studies. If you want to have mentoring and teaching, maybe you want a junior engineer here. And now we're coming back to the risk. Well, then some automatic approaches where you have like a round robin are not the best, because a high risk change, for example, shouldn't be assigned to a junior engineer. So it's a little bit more complicated here. But what you can definitely do is you can work on smaller reviews. That's so important, right? Small and coherent changes. And how you do that? Well, with feature flagging. So you're working on smaller things and you just push that out in production even, right? While you're still developing it. It also means that you're heavy branching and using Git to really make sure that you're reviewing smaller code things. So this is a study also from Cisco where we see the correlation between logs, lines of code under review and time, and you see that there is a correlation, right? It goes down, and it's not the same as before, because here it doesn't matter how long the people have time. So you can give them 2 hours a day. We still see that they're not finding the defects if there are so many things. And we did a similar study at Microsoft, and here you see not the lines of code, but the number of files in the change set. And you see it goes down, right? So the percentage of useful comments decreases drastically with the number of files in the change set. So you want independent and self-contained code changes. And this is a little bit tricky, but let's have a toy example. Let's say you're working on a feature, and while you're in the first file, right, you see something, and you enact the Boy Scout rule, and you say, well, I'm renaming this here. It's a refactoring. And then you see a fix, right? You have to fix something because you revealed a bug while doing this feature. And so you actually go into other files and you're doing things here. Well, now you're sending this out because it's trivial to you, right? It's called the expert blind spot again, right? So it's really trivial to you, but it's actually hard for the others to understand. It would be much better if this, would be extracted in one pull request or in one code review, and then a fix would be in one code review and the feature in one, because then you have a coherent file or change set, and it's more easy for the other person to understand. And understanding code comprehension is really tricky in code reviews. Right? So you want actually to do that. And you can use, for example, this is just one approach. There are many, many approaches, but this is one approach. You could have like review branches for that, right? So instead of committing everything on one work in progress pull request and then have this request, and people could also use like commit-based reviews. But it's also nice if you have like each of those steps as a separate branch, which is on top of the other branch, which also means you can send it out for review and can work further. And then you send it out for review and work further. And it's really better for code comprehension to do it that way. Well, this brings me somehow to the end. I know it was very short. I was given 20 minutes, so I tried to put as much information as I could in there, and I really focused on the productivity part here. So really small coherent changes are the key, and there are a lot of techniques that you can actually do to do that. It takes a little bit of training, it takes a little bit of practicing, a little bit of muscle memory, right? A little bit like the single responsibility principle also not comes to you. You have to actually learn it and apply it. But then I think it's very, very powerful, and you have to think about how do we organize that it's actually fitting our goals, right? How are we going to do code reviews as a collective, as a team, so that nobody actually suffers? One has this pile of reviews and the other does nothing, or you're waiting too long. In general, code reviews, if you work on your communication skills, so important. Knowing what to look for in code reviews, really, really important. Reducing reviewer burden is also very important, also to speed up code reviews. Clear guidelines and policies, very important to speed them up. And as I said, education and training. If you have brown bags around that, really make code reviews a topic that is discussed and treated with respect and deliberately improved in your organization. I think this is very, very important. So if you want, you can follow me on Twitter. And now I think it's time for questions and the discussion. There's also a free ebook if you want to download that. And feel free to reach out to me. Thank you so much for listening to my talk.
Hello, friends. I'm so happy to be here talking about developer productivity with you. And I'm going to talk about 10 different tips and tools that you can adopt in 15 minutes or less each. So these are a bunch of little ideas that maybe you've heard of, maybe you haven't. And if you want to adopt them, it's not a lot of effort. You can just try something out. So no big commitments here and a bunch of things to choose from. Let's get started. We're going to go through the 10 tips and you'll see a few examples along the way. First of all, let's talk about the command prompt, shell, terminal, whether you're on Windows or Mac or Linux. We're always, as a developer, working with the command line. There's all sorts of things we have to do to get our jobs done. But if you open up your terminal and it looks like this, or you open up your command prompt on Windows and it looks like basic cmd.exe, that's a problem. You're missing a huge opportunity for a very, very powerful system to do a whole bunch more. So let's look at another option. Over here, we have my terminal on my Mac OS here. And notice there's some colors going on. If I type something like Control C, you can see that there's a little red arrow instead of a green arrow. That means that last command failed. Let's go over to a more interesting directory, one that is, say, a GitHub repository. Notice the prompt changes, and over here you can see git:\master. It actually shows you the branch, the status of the Git in this repository that we're in. We do an ls, we get colors for like directories versus files, all sorts of cool stuff there. There's great autocomplete. So for example, if I want to go back in my history and just see all the things I've done with brew, I just hit brew and then up arrow, and it just shows me all the commands that I previously run by using the arrow key that start with brew. That's fantastic. And you even get autocomplete for higher order things such as, well, Git. So if I know I want a branch, I think, or something start with a B, I hit tab and it says, oh, you could bisect or you could branch. And I can even tab over and hit that one. So yep, that's actually the one that I wanted. So this is Oh My Z Shell. The recommendation is maybe check out Oh My Z Shell, but the real recommendation here is to just look at some alternatives. So for Mac OS and for Linux, I strongly recommend Oh My Z Shell. I think it's really, really great. There's many other options as well. If you're on Windows, you can use Oh My Posh. And this actually works in other places. Notice this part right here, all these colors. You've got the green, you've got, actually here's the Git repository and the changes, all the stuff going on here. So really, really nice. This works on PowerShell, for example. So Oh My Z Shell doesn't. All right, so first recommendation is get a very proper shell that is built for developers to do developer things, and really you're going to be super happy. Finally, if you're on Windows, don't use command prompt, and maybe don't even use straight PowerShell directly. Use the new Windows terminal. You can see the link at the bottom. It's much better than what you had before. Number 2, security. If you run a web app, you want to make sure that your web app is secure. Well, how do you do that? You can go check in with OWASP, the Open Web Application Security Project. They have all these recommendations and top 10 security holes or problems that we've seen over time. But how do you keep up with them? How do you keep them in your app? Well, there's this really cool project called Secure, a package called Secure or Secure Pi over in the Python space. And if you're not a Python person, just hang tight. What you can do is very simply create one of these secure headers, and you just go to your framework. For example, here in this tween section, you write these 3 lines of code and you say secure headers.framework.pyramid, upgrade this response to a secure one, or with Flask or with Django. It supports many, many Python frameworks. And if you do this, come back over here and have a quick look. We're doing that over on Talk Python training. Let's do a request and we'll see what headers we get back from our requests. We look at our headers, notice there's 12 responses, and we get things like strict transport security, X-frame embedding options to prevent people from embedding our responses, no sniff, restricted refer policies, and so on. All of these are put into our requests automatically by SecurePy. Again, if you're not a Python person, maybe you're in .NET, you work with ASP.NET, there's something like this called NWebSec, and you can see this link here to a blog post by Scott Hanselman that talks about it. If you're in another technology, there's likely a library like this that you can just plug in and add all these secure headers that make your website, well, more secure. Number 3, we saw the command prompt. Well, you shouldn't only use command prompts. maybe if you're doing Git, you should think about using some kind of GUI. I know a lot of people want to just keep it straight, simple, and easy and just use the command prompt, but there's a lot of things you can see with a proper UI. So I recommend that you check out SourceTree. SourceTree is a Git client, a Git GUI, and it seems to have almost all of the features of Git. So if you want to do pushes, rebases, and all sorts of, sort of more advanced types of things, all those are still there. It doesn't hide very much from you, but you get the benefit of having a lot more visual information. You can also check out GitHub Desktop. That works on all the OSs. If you're working with an IDE like PyCharm or Visual Studio, they come with built-in Git. So consider using that there. Like in this example, you can see this commit is going to add a function, can evade, to this class here. That's way better than just, git add dot git commit dash m. I think I remember what I did. You can see exactly what you did. And even with the Visual Studio and PyCharm or IntelliJ, you can access things like pull requests and check them out, check out what's going to happen, play with it, and then decide whether or not you're going to approve it. So all sorts of good stuff. Visual Studio Code has it built in as well. So be sure to remember your UIs for Git. Speaking of Git, have you ever created a fork of a repository? So you find something you like. So for example, here we have the secure project that I was just telling you about before. I forked it over to my personal GitHub repository. But as that library, the original, changes, you're going to be behind, and maybe you don't want to be. Traditionally, what you've had to do is you've had to go to the command prompt, you've had to go and add an origin, and then pull the origin, and then check out the main branch, and then merge the origin into the main, and then you commit that back, and just to keep it in sync. So GitHub recently added a fetch upstream to all forks. So if I go to my fork page, it says, oh, your fork is 2 commits behind, click fetch and merge, and we will just catch it up. So if you have a forked repo that you really care about, be sure to do this because it'll keep you in sync much easier than before. Error logging and reporting. You're probably logging, right? In your technology, Python, .NET, Java, whatever it is, they all come with built-in logging frameworks. And my experience is they're almost all bad. I don't know why, but they just kind of seem clumsy to use. They're a little bit extra work, or they're over-designed, or you name it. So I encourage you to check out some cool external logging packages that you can bring in. So in the Python world, I use something called Logbook, which is a really simple, nice way to create rotating files for your log files and add extra info. Another really popular one is Loguru, and really, really nice. And regardless of what technology you're working in, I'm sure that there's some much better logging frameworks. But also, it's not just about putting messages into files. It's about notifications and tracking and categorization and stuff. So look into services like Sentry, where you can do a little integration with your site. And if there's an error or other types of information, that'll automatically get saved at Sentry. Then you'll get a notification, hey, there was an error in your site. And you can go see the log, you can see the traceback or the stack trace and figure out what's going on. You'll see all the variables, maybe who was logged in. Super, super helpful. So better logging with better packages. Don't just do the default usually. And then you can actually add some services on for notification and much better stuff. So you actually know what's going on in your site. Speaking of sites, you want to keep them secure. It used to be that you'd have to pay $200 and get approved for an SSL certificate. That's completely silly. Those days are long gone. Let's Encrypt is now a thing that automatically generates free SSL certificates. So if you've got a website, it needs to have SSL. Google is treating websites that are not secure, as not secure, and they're not showing up as well in search results. They're being sort of looked down upon in the UI of things like Chrome and so on. So you really want to have SSL, even if you don't really need it for your site. I mean, maybe you're not actually storing anything secure, but the infrastructure of the web is starting to expect it, so you want it. Adding Let's Encrypt to your site, if it's hosted on Linux, is incredibly easy. You basically add a repository for the universe. You say apt-get install certbot, Python 3 certbot nginx, And then all you have to do is say certbot --nginx. It looks at all the domains that are set up under, say, nginx, and it'll suggest creating and maintaining and automatically renewing certificates for that. It supports other servers other than nginx. It just happens to be the example I have here. So you can see the docs down at the bottom there. But if you've got a website and you're in charge of running the server, make sure that you use something like Let's Encrypt so that it's secure. This one is a very fun one. If you want to have unit tests for a web app, web API, something like that, one thing you can do is sit down and write a whole bunch of tests. And you probably should do that. You should be testing your code, of course. But there's a really, really simple technique. I almost said trick. It's not really a trick. It's a technique, or a shortcut, maybe is the best word, for really quickly just deciding if your site mostly works. Because when it breaks, it's not like, well, the box is off to the side or this piece is hidden. No, usually what happens when a website breaks is it crashes the server, 500 error, and it breaks hard. So if your site has a sitemap, and it likely does because you want it to look good, you want it to present itself to Google, right? This is an XML document that shows what URLs are there. You can leverage the sitemap to basically request every single page on your site as part of an integration test and decide, is it working or is it not working? So let's check that out over here. So over at Talk Python to Me, the podcast website, we have a sitemap, as you can imagine. These have lots of pages. For example, the Talk Python training one has about 4,000 pages listed in its sitemap. And what we can do in this one is we can go and just write a very small test here that will go and request the sitemap, then use a little XPath XML DOM stuff to figure out what all the URLs are, convert them from global, because you don't want to request the production one, you want to request your test one, and then just run it. So if we go over here and just run this test individually, you can see down at the bottom here, it's just going and hitting every single one of these pages, and it's cranking through it. I think there's probably 300 or 400 here for this site. And every one of them passed. So, hey, it looks like your test passed. How long did that take? 10 seconds. Not very long at all. But it's a really simple and easy way to make sure the site is going. And what's cool is when you add something new, the sitemap is updated, right? You add something in the database, it regenerates the sitemap because you want that to show up for search. Well, you can just piggyback on that and make sure that those pages keep working all the time through continuous integration and so on. So super, super easy technique here to just run a simple request against every page that you have on your site and make sure that it, well, doesn't break. Here's a simple code, at least in Python. Set up some test code, get a hold of the sitemap.xml, and then, as we saw, just use XML processing to pull out the URLs and then request every single one of those individually. If they all work with a 200 or a 201 or something like that, maybe even a 302, they don't do 404s and they don't do 500s, you're in a really good place. All right. Somewhat related to the SSL thing, Google is also treating sites that are not fast and don't provide a good user experience less well, as in deranking them in search and so on. And one really, really important site that you can check is called PageSpeed Insights. This is from Google. You can put your URL in here. And if you've never done this, prepare yourself to be somewhat disappointed. So for example, I put in Talk Python training here. That website responds usually from a request hitting the server till it goes out the other side, usually 10 to 30 milliseconds. And I thought, well, of course, Google's going to think this site is fast. That's fantastic, right? Nope. I put that in there, and I think you can see the little scale here at the bottom. I think I got a 55. That's the bottom end of slow to average. I'm like, whoa, this is a problem. How is this possible? Well, it's possible because it doesn't take into just the server response time for websites. You know, what it looks at is, well, if you serve large images and they have to be resized, and it's say on a phone, well, how much time is that going to take? And well, how long is it until the JavaScript renders the front end bits so the user actually sees that? And is there a lot of JavaScript that's slowing down the page? And so on and so on. So there's many, many different things that you can work on. And if you scroll down and you put your site in here and you scroll down on this page, you'll see tons of concrete recommendations. So I got my 55 or whatever it was, and I was disappointed, but I went through the recommendations and I didn't take all of them, but I took many of them. And now you can see 99. That is super, super cool. I still have a little work to do on mobile. They added some new tests that I got to come back to, I suppose. But really, if you have a website and you want it to rank high and have a good user experience, this is incredibly helpful. If you have to install software, you go and download it. If I want Python, do I go to python.org and download it? If I want Node, do I go and download Node and install it? I can. What if there's an update? How do I know there's an update? How do I perform that update, right? So do I go download it again and install it over top of the old one? No, don't do that. Use something like Homebrew. If you're on macOS, Homebrew is fantastic because you can say brew install MongoDB, and now you have MongoDB. Plus, anytime there's updates, it'll just automatically update it for you. Brew install Python will give you the latest Python 3. If you're not on macOS, maybe you're on Linux, well, Linux has it built in, right? This is the one place where Linux has had this all the time, right? We've got apt on Ubuntu and so on. So nothing to do if you're on Linux, but if you're on Windows, you can't use Homebrew. And Windows, this is not a very common idea, but I would recommend you check out Chocolatey. Chocolatey is the same idea. You can say, I want to install this library or this package or this application, and it'll download it and its dependencies and keep it up to date for you. Speaking of dependencies, number 10, the last one, if you've got a web app or any kind of app really, but it's super important that you keep the dependencies up to date and fresh, but especially if something that has an open port on the internet, it's even more important. So let's go through what this might look like. Well, you can say, I have tools that I just installed. So say in Python, I would say pip install pyramid to get the pyramid web framework. No big deal. It's great. That gives me the latest. Well, unless you've already got it installed, then you get the message, the requirement is already satisfied. Even if it's old, even if it's out of date, no, you have it installed. No big deal. I'll just add the -- upgrade. That'll get me the latest. Nope. It does give you the latest, but there's a bunch of dependencies that themselves, when you install Pyramid, it traverses the dependencies and installs those. Those also have to be separately updated. Now what? What if there's a security issue? Like what if there's a vulnerability in Pyramid? I need to fix it right away. Will I get a notification or do I have to remember to do this all the time? No big deal. You pin your version and GitHub will give you updates. Yes. But do you get regular feature updates or only important updates about security bugs, right? So you can use Dependabot, which is now part of GitHub. They were acquired by GitHub, and they will look at your requirements for your different technologies, whether it's Node.js or .NET or Python or whatever, and it will tell you when there are new dependencies and actually do PRs over to your repository. So if you've got something on GitHub and you have some kind of requirements file, go ahead and add Dependabot to that. That's great. You can also use pyup.io. I kind of like how they work better, but they're a paid service and they're not part of GitHub, so you can decide. And of course, that one's just for Python, right? Dependabot is more broad. All right, well, that is it. Those are the 10 tips. Thank you for taking the time to watch. I hope you found them useful. If you want to follow me on Twitter, follow me over there. I'm at mkennedy. If you want to learn more about these kinds of things, especially with the Python bent, check out Talk Python to Me, one of the podcasts that I run that does like deep, long form conversations, and then Python Bytes, which is like a weekly newsletter with analysis in the Python and technology space. And of course, if you want to learn things about Python and that ecosystem, check out Talk Python Training. With that, thanks so much. It's been great to be here with you.
Hi, my name is Nishant Bhajaria, and this is a quick video for my upcoming book with Manning Publications called Privacy Engineering. I'm super excited about this book because this book answers, I believe, one of the key questions for so many engineers, program managers, product managers, IT specialists, and security specialists all across the world, especially those who work in smaller, fast-moving companies, even medium-sized companies, or for that matter, even larger companies. You have a finite set of resources. You need to get products out the door, you need to build features, you need to monetize your data, and you need to do it pretty quickly. So time is pretty precious, resources are pretty limited. So that's kind of the world we all live in right now. And I've optimized this for small and medium-sized companies, but really this is also a challenge for big companies too. And this is where I come in. I began my career in this space, in the identity, security, privacy space about more than a decade ago. The goal at the time was, how do we make sign-ons more frictionless? How do we get more people on board? This was the time when people were getting onto the cloud for the first time. This is when global IDs were becoming more famous with Google and Facebook for the first time. Mobile computing was becoming a big deal. So at the time, the door was just starting to grow and people were trying to build a platform to get more people onto their platform, if you will. And in that sense, it was more about, is this business going to work? At this point, more than 10 years out, there is no doubt that the business is working. More and more people are getting on the platform. People are getting on the tools. People are using their mobile devices all across the board. The data is streaming into the cloud. And now the attack vector has shifted completely. Now it's about, how do we make sure that this data is kept safe? How do we make sure that we build trust with our users? How do we make sure that the global regulations are followed? So somehow, with very, very quickly, you have gone from get everybody on the door and get their data to how do we make sure that their data is safe? It's almost like the middle period of just being able to collect data and caching it never existed, but really it did exist. There is a reason why Microsoft, Google, and AWS have huge cloud businesses. All those bills are being paid with cloud data. Data that we collect, data that we store, data that we monetize, data that we join with other data from third-party vendors. So we have a responsibility to make sure that the data is kept safe. And it's not just a good to have altruistic motive here. If we don't keep data safe, our ability to build trust with the customers is gone, which means customers' willingness to engage with us is gone, which means our ability to drive more engagement is gone. That's the kind of the bad perspective. The other perspective, which is equally bad, is that if people don't trust us to keep their data safe, their quality of engagement will not be very high, which means the quality of data we get from them will not be very high, which means they might give us data that is not correct, not reliable, not worthy of more engagement. And that is the foundational data upon which we build our engagement model. So we need to make sure that customers are kept safe on our platform, not just because of GDPR or CCPA or whatever law you've heard of. It's purely a business imperative to make sure that your data is kept safe. Now, in my upcoming book titled Privacy Engineering, we talk about its essential data protection all across the board. We talk about the relationship between security and privacy, why it's important that you look at security much more holistically. We look at privacy tech, all the upcoming books, all the upcoming privacy tools ranging from Big ID to Privatar to Privacera to Datadog to DataGrail to Wirewheel, all these tools. What do they mean? Should companies build or should companies buy these tools? That's kind of the use case here. I'm looking at the larger space in terms of regulation. What does GDPR mean? What does CCPA mean? Why are they different from each other? How are they different? What has the impact been of those laws on big companies versus small companies? Because remember, when these laws were passed, the prevailing sense in the regulatory climate was that there is a need to bring the big tech companies to heel. What has in fact happened over the last 3 years is that ever since these laws have become official, the big tech companies have done really well and the smaller companies have struggled. And that is because there is a bias in the law, not intentionally, but to make sure that you have more process, more rigidity, more demonstrable audit capabilities and whatnot. The big companies can do it pretty quickly because they have people like me on their payroll. What do small companies do? Companies where it's only one person doing IT, privacy, security, compliance, audit, right? It's very hard to do that. So this book is meant to be a weapon for those sorts of individuals. There is a significant investment in the book on data itself. How do you classify and inventory data? The whole purpose behind this is when you collect customer data, you need to have a sense of what the risk level is attendant to the data itself. Is it high risk? Is it low risk? Is it medium risk, etc.? That's kind of the use case behind the data. How do you adjudicate that level of risk? How do you work with the engineering teams that collect the data, whose endpoints, API gateways are essentially the welcome mat for the data? How do you then talk to the data science folks, the data analysts who use that data to build ML models, to build the dashboards, who pry into the logs with their queries? How do you then work with the API vendors on the inside who get that data out to third parties and whatnot? How do you build out a lineage of data, not just from an ingest perspective, but an overall usage perspective to ensure that the data gets used correctly? The way you do that is you build out automated detection controls, automated management enforcement controls, but that doesn't even begin to start unless and until you have a sense of what the data is. So there are 2 chapters that talk in detail about how you come up with classification. There's a lot of detailed examples to boot here. And then there's also a lot of detail in terms of how do you build out a categorization system? How do you inventory data at the database layer, at the bucket layer, at the row and column layer, how do you build out machine readable tags and affix those tags to the data to make sure that when any engineer makes decisions around that data, they do so with a proper understanding of what the data actually is. I've often been in this situation where people tell me, if only engineers had the right context, they would make the right decisions. And that's true so far as it goes. But when you talk about engineers collecting petabytes of data, when you talk about them running hundreds and thousands of queries on a daily basis, a lot of these queries are even automated. Good intentions aren't enough. You need to make sure that the tooling, the automation, the logic is meshed into the data itself, so that when people make the decisions they do, 1,000 decisions per second sometimes, those can be constantly validated with a deterministic method with the data itself, right? So essentially, if you have if you're collecting somebody's biometric information, for example, and there better be a good use case for that. And I talk a lot about what GDPR talks about in terms of why you can collect somebody's data. Once you have that cleared away, you need to come up with a proper label that decides that this is identifying data that is very, very sensitive, that maps back to a specific individual. You come up with a tag for that. You affix that tag to the data in a way that can be read by processes and tools across the company, automated processes, by the way. How do you make sure that that penetrates across the board? And remember, as a company, when you start this process, you will be starting this with a ton of data under your bonnet already. In other words, you won't be starting from scratch. You'll be starting on third base or something, except it's not a positive third base. You have a ton of tech debt. So you have to make sure that culturally the company does the right thing from the get-go, in the sense where every bit of data collected this point forward is tagged, and every bit of data that you have collected already is tagged looking back. So you have to do a bunch of catching up to it. It's a bit like jumping on the treadmill that is already moving. You don't get a chance to set the incline and the velocity. You have to pretty much run, get your balance, burn your calories all at once. That's what this book helps you do. But this is very, very important, because as a small business, as a large business, as a medium-sized business, the key is you are moving fast, and you need to get these things going as quickly as possible, because the sooner you get this done, the easier your privacy program will be. It's like my colleague at Netflix used to say, my peer who reported to the company CISO like me would say, the best time to do things like these is yesterday, the second best time is today, the third best time is tomorrow, the worst time is later. So you want to make sure that you get these processes going as quickly as possible. The good thing is this book has explanation conceptually. It explains the tooling, it explains with examples, and it shows you how to take care of this end to end. This should be a helpful tool for all of you. The book also has a detailed chapter on data sharing, and we talk about how the New York Times journalists were able to track President Trump when he was having dinner with Prime Minister Abe of Japan. They were able to track his movements all across Mar-a-Lago at the golf course, dinner with Prime Minister Abe. And the reason that happened is because somebody on the president's touring party, I believe it was a Secret Service agent, had a smartphone with an app on the smartphone that was broadcasting their location. So the president's location was not being broadcast, but the location of the Secret Service agent was being broadcast. And as a result, people were able to decipher where Mr. Trump was traveling across the board. Not just that, they were able to track a whole bunch of other people as well, because you can find out via third-party information, via internet information and whatnot, who else is in the party, and you can track them all the way through, simply because one person in the contingent was broadcasting their location information. So to that end, in that chapter, I've given examples of how data sharing is a reality, how we can share data in a way that protects privacy, so that the people who should be getting the data are able to get the data and are able to get it safely, securely, and able to use it correctly. But the people who aren't supposed to get the data, and if they manage to get a hold of it, how do you make sure that the data is privacy protected? In other words, you can obfuscate the data, you can round up beginning points, end points, you can round off starting points, end points, you can essentially obfuscate IP addresses, GPS locations, and whatnot. And collectively, that means rather than being the only person in the cohort with a specific set of values, you are now sharing that information with a whole bunch of other people. So as an example, rather than being the only people that began a trip at 11:03 p.m. and ended the trip at 11:50 p.m., you become one of 5 people that began the trip at 11 p.m. and one of 7 people that ended the trip at, say, close to midnight. By rounding off those starting points and end points, you now become part of a much bigger cohort rather than being a singular identified value, which becomes important because if you are, say, in a country that is targeting you for whatever reason, or you are being reached out in a way that you would not want to be reached out because you're being identified, these values allow a level of privacy protection. So there's that. There is a chapter on deletion. How do you delete data that is real-time account data in databases like Cassandra, MongoDB, as well as archival data in databases like Hadoop and Hive? How do you make sure that you overcome the append-only capabilities? How do you set up a service that schedules deletion and then sends a message to another API that collects the data so that you can mark deletions in a way that does not disrupt regular businesses, but at the same time enforces policies like retention, deletion, time periods, and whatnot. So you have the legal team setting policy, you have the privacy engineers building an API to schedule deletion, and then you have the service owners themselves who actually do the deletion of the data. So you have the shared responsibility model that I've explained in great detail. I've talked about a privacy review process. How do you automate a privacy review process ranging from the intake of the engineering proposals to the reviews themselves, to the elimination of privacy risks, to the mitigation tracking, to the criteria to allocate different levels of risk to different engineering projects. There's a ton of detail there on that front. Now you can pretty much set up a program using the book. Now, the key is most of you will not be able to use the chapter as it is from a privacy review perspective because every company is different, every review process is different. What this chapter will do for you is it'll give you a pretty clear sense of what are the trade-offs, what are the value propositions, what are the use cases, and then you can essentially build it out from that point forward. And the hope is to give you enough information that you can avoid making some of the mistakes I made back in the day. At the same time, it gives you enough sort of beacons that you can emulate or avoid, if you will. These are the things that may or may not work for you. So that's kind of important as well. There is also a chapter on what is known as DSARs, which is Data Subject Access Requests. Because of GDPR and CCPA, customers, that is people who come to your website and whose data you have, now have the ability to ask you for a copy of their data. They can email you and say, I'm paraphrasing a little bit, so you want to check with your general counsel in your company or the legal teams or outside counsel, but they can email you and say, hey, company XYZ, give me a copy of all the data you have about me. How do you get that information? How do you get that data? How do you extract it? How do you come up with the time periods or look back periods? How do you transport the data? What security considerations apply? How do you decide what data is in scope of DSAR and what's not? So there is a chapter that discusses this in detail. Now, there are a ton of tools in the market that promise you DSAR capabilities. At the end of the day, though, only you know where your data lives. And there is a difference between a tool that packages data that you have extracted and a tool that actually locates the data for you in your data store. And that's what this chapter talks about. So I would strongly encourage you to look at this chapter in great detail as well. Another chapter that I've spent a lot of time discussing is the chapter on consents. My favorite example of a consent is when you and I were getting used to the internet for the first time in terms of e-commerce, maybe say 15, 20 years ago. Those of us in the US, when we would sign into accounts, we were basically given a checkbox saying that by clicking submit, I am essentially accepting the terms of use and privacy policy. Oftentimes, it wasn't even a checkbox, it was just text, which meant that by signing on to a website, we were essentially opting into marketing communication. At the same time, our counterparts in Europe had to explicitly check in the box, which means they were given the permission, they were given the flexibility where they could explicitly check in. And if they didn't check in, they were considered to have opted out. In the US, we didn't have that flexibility. Now, partly because of GDPR and CCPA, and partly because of industry movers like Apple themselves, the sentiment is shifting. Customers are considered to be opted out, and they would have to consciously opt in to be able to get marketing materials from the company, which means it gives customers the ability to decide how much communication they want from the company. Even more critically, it gives them the ability to consciously opt out of having their data collected, which is a huge win for privacy for those customers, because logic dictates that if you are preemptively opted in, you might not opt out and the company can collect your data, use that for personalization, monetization, things like that. The laws that are coming up now, and GDPR is just the beginning, my anticipation is there'll be a bunch of state level privacy laws in the US that will emulate GDPR, that will essentially give customers the same power. So now you as a company need to build a consent management program that locates customers' consent in a very accurate, timely fashion, and that gives you the confidence that you have the permission from the users to collect their data. And you have to make it easy for them to withdraw consent just as you do for yourself to get their consent. So that's pretty important as well. So now in this use case, you are looking to make sure that you do right by yourself and your customer. So there's a lot of code, a lot of examples, a lot of insights in that consent management chapter. There is also a chapter on security, specifically from an AppSec or platform security, product security perspective, vulnerabilities around shared password, lack of multi-factor authentication, weaknesses, secrets, and identities in the code. How do all that lead to security risks, which in turn lead to privacy risks? So when the book comes out, the Colonial Pipeline hack that took place very recently may have receded into memory. But the fact of the matter is, based on current information, the Colonial hack happened because they didn't have multi-factor authentication, and there was a compromise of an account that was being used for VPN purposes. So you basically had an account and a password get compromised, the identity and the password get compromised. The corresponding account was not being used, but was also not disabled as it probably should have been. It was not in scope of an MFA as it should have been. And as a result, an outside exfiltrator was able to get into the Colonial Pipeline and shut down gas supply for so many states in the East Coast, and gas prices went up. This could happen to food supply, this could happen to electric supply, this could happen to banking. So certain privacy risks at the application platform infra layer become privacy risks, because once somebody gets into your system and becomes a pseudo admin, they can increase their privileges. They can essentially operate into your account as if they are your account themselves. Essentially, they can act as the admin, they can impersonate a customer, malware, phishing, spam, everything's on the table. And at some point, any level of security risk becomes a privacy risk as well. So I have a chapter that covers that in detail. In the chapter, I also talk about how certain efforts that help security hurt privacy. So in some cases, you improve security, you improve privacy. But in some cases, you improve security, but you hurt privacy. So where are the examples where there is tension? So I've talked about that as well. And then, of course, there is a last chapter that talks about things like advertising, talks about things like the changes Google is making on the third-party cookie side, why it's important for companies to increasingly pay attention to regulators, why it's important to build this community of people that are privacy and security advocates, because this is a brand new field that when you can hire somebody with, like, say, 15 years of experience in iOS, because it has been that long since Steve Jobs walked on stage with his hipster mug, we don't have that level of bench on the security and privacy side. So it's important to build a community and have government, think tanks, industry work together. So there's a chapter that talks about that. My hope overall is that when you work for a company that has historically optimized for growth, for engagement, for customers, and is now suddenly confronting this tremendous challenge on security and privacy, how do you get started? How do you make sure that you're on the right track? How do you quantify those risks? How do you start measuring progress? How do you build the work going forward? How do you optimize for improvements? How do you scale for maturity? How do you build a program around it? And how do you do all this without creating a whole bunch of burdensome process, without slowing down your engineers who are legitimately trying to build a better product, right? So that's what this book is about. It's about helping your business without hurting privacy. It's about growing privacy without hurting your business. There is a way where you can do both at the same time. That's what this book is about. It's a book intended for engineers, but I believe it'll help product managers, compliance specialists, attorneys, people in media, executives, everyone, because I feel like the gap between the engineers, their day-to-day life on the one side, and the business's strategic goal on the other is where privacy risk begins. The larger the gap, the larger the privacy risk. And this book is aimed at a doorstop between those risks, if you will. So my hope is start with the engineers in your company, but beyond that, make sure that everybody in the company reads this book, because there is something in it for everyone. There are chapters in the book that may not apply to you. Some chapters will, some chapters may not. But then there are others in the company for whom those other chapters will be helpful. So this is a book for everyone. My strong advice is please read it, because it has a lot of lessons I learned the hard way. Because when I got into the cybersecurity field, none of this existed. The lessons didn't exist, the learnings didn't exist, the tutorials didn't exist, but the risks were not that high. Now we have a lot more resources, a lot more talent, but the risk vector has gone up. The attackers have gone up in number, the amount of data has gone up, the fines have gone up, the scrutiny has gone up as well. So this book is aimed at making sure that people land on their feet, that they can keep growing, and then they can respect their customers' data and help their business at the same time. My name again is Nishant Bhajaria. You can find me on LinkedIn. The book's name is Privacy Engineering by Manning Publications. Thank you very much for listening.
Hi, my name is Chris Love, and I'm here to talk to you today about developing with Kubernetes. And one of the problems that we have with developing with Kubernetes applications is really how big Kubernetes is. And what I mean by that is we either have to create a cluster in the cloud to develop with, or we're running some sort of complex application or Kubernetes stack locally. Typically, what I found is most companies have development clusters where their engineers are developing on. And to me, that doesn't make a really effective development experience for developers, where you have to go into the cloud or some other place to test your applications. When I'm developing, maybe I'm just old school, but I still like running the applications locally. Running Kubernetes locally, to be honest, is quite complex. It's a very large application, and there's lots of complexities to starting and running Kubernetes. So today I'm here to talk to you about a tool called Kind. It's K-I-N-D. It is maintained by the folks over at Kubernetes that develop Kubernetes. It's actually Google test team and a bunch of other great folks over there. What it does is it's a Go tool. So it's a Go binary you install locally on your development machine. And you run it, and it creates a full cluster of Kubernetes for you. What it does is it pulls down an image that contains all of Kubernetes control plane, and it spins that image up for you. Has a full API behind it and can do lots of different things. Let's, within the project that I have, or I've created a GitHub project for this demo. I've actually created a short link for it. It's bit.ly, so bit.ly/kind, K-I-N-D, -talk, T-A-L-K. So if you want to go to that project and follow along, great. Otherwise, we're going to dive into the makefile here. And we're going to do a couple things. First off, we're going to create a local registry for your images. And we're also going to create a kind cluster. Now, we've got the make commands here. So we've got kind installed locally. We've also got kube control installed locally. And we've got a container image running. So if we just do make create kind, it's going to create a registry for us, and then it's going to spin up the kind test node image. It's going to take a few seconds because it's going to start up the control plane and everything for us. So while that's going on, let's go over and take just a quick peek at one of the scripts that we just ran. So inside the kind folder that we have, we've got a start local registry. All that does is it starts and double checks to see if the image is running. And then if it is, it starts, oh, that's the stop local registry script. Let me get to the start registry script. There we go. See if I can, it's because I called it set up local registry. So it's going to start an image called kind-registry if it doesn't exist, and it's going to use the reg2 image to start it up. It's also going to create a Docker network connection so that kind can connect into this registry. So that's spun up. If you look at a Docker PS, we've got the registry image running right now, and we also have kind node image running right now. So if we go back to our other window, it's all set up for us. It ensured that we have the right image locally on our machine. It prepared the nodes, created a configuration file, installed networking for us, installed storage class so we can do stuff like PVCs, and then even set up our kube control information for us, our kube config. So if we do kube config -n kube system get PO, it's going to show all the pods that are running. We've got Coordinas up and running, etcd, kindnet, which is our CNI provider, which is how pods get IP addresses with and are able to communicate. API server, controller manager, proxy, and also the schedulers all up and running for us. So as I mentioned, it has a full API behind it. So what we just run is a kind create command and use this piece of YAML or this YAML file as our configuration file. You can just do a kind create without the configuration file and it spins it up. For this demo, we're doing a couple different things. First off, we're mapping some ports because later on we're going to create node ports. So we're mapping a container port to a host port, setting up the protocol for that. Also, what we're doing is we're setting up a containerd configuration so that containerd, which is a container engine that's running within the registry. So we have locally here, I have Docker image, but we're running Docker in Docker is what it's called, but this time it's Docker with containerd running. So we're actually going to run an image within an image. The configuration lines on line 14 here allows us to talk to a local registry, which of course I showed you that we spun up. So within this project, we also have just a Docker file and a server.go file or a main.go file within a just basic HTTP server. This is a two-stage Docker file we're going to use to run a Go build, and we're also going to package it up and run the binary. So we've got commands, and let's go back into the make file real quick and walk through this. So you notice on line 21, I've got a Docker push. That's going to do is run a Docker build on that Docker file we just looked at, and it's going to create, you notice that there's a variable in there called registry host. It's all the way at the top. I'm not going to scroll back up, but it's localhost :5000 where our local registry is running. We're going to do a Docker build, and then we're going to do a Docker push, which is going to push it up to that local registry, which is running locally. So we do a make Docker push. So that's going to run our build for us. It's using a local container. It's a two-stage Docker build. So it runs Docker to build the file. Then we have the Go file locally from the build, and then it'll create the actual image that we're using, and the image is localhost :5000/API. We then run the Docker push command, and that pushes it up to the registry for us. So now let's recap here. We've got a client Kubernetes cluster up and running. We have a Go application up and running. So if we take a look under server, there's a main.go, and it's just a real simple application that's a simple hello world. We're listening and serving on port 8080, and then we're just going to output some JSON. So in order to get a deployment up and running, of course, we need our deployment YAML. Very simple deployment YAML that you'll be, if you've worked with Kubernetes before, you're very familiar with it. The line that's important is line 20. So you'll notice that is pointing to localhost 5000 API :latest. So that's the image that's running, that is hosted by our local registry. That's going to get pulled in by kind. So if we do kube control create -f kind.yaml. Oh, sorry, wrong file. There we go. So that created a deployment for us in the default namespace. I've got kube control alias to k. So we can see that we've got the simple server up and running. So we built the image locally, pushed it to the registry. Now we've deployed the YAML file, and we've got the application up and running. So one of the nice things I can do is I can go in, so I can run a kube control port forward to this pod on 8080. And I can go over to my browser, and I can go to 8080. That's not quite what I wanted to do. There we go. And we've got the message, hello universe. So if we go back to our command line, and we do some development work, and we really need to have hello world, not universe, then we can just do, again, the Docker push. And again, that's rebuilding our image for us using Go. And then it's going to push it up to the local registry again. And when that's done in a couple seconds, we can do a kube control delete -f. So that deleted our app for us. And then we can do kube control create -f. And that created our application again. So, and again, it's running, it's 4 seconds old. So if we do, again, we go back to the port mapping, port forward rather, on this pod on 8080. we've got hello world instead of hello universe. Really handy. Really, you can see how quickly I did that. I'm not worried about external registries. I'm not worried about being able to connect to different places. Just working off my development machine here. So as we noticed, if we go back to the kind.yaml that we set up, we did the extra port mappings. And the extra port mappings are for the node port that we're about to set up. So realistically, we should be running a service. We shouldn't be just port forwarding to our application. So if we go back in the make file, we've got a create service command down on line 30 here. That's going to create the node port for us. So what we ran, kube control service, node port, simple service, right? We're going to bind 8080, which is the port that's running on the deployment, over the node port that we set up. So in essence, we created a node port on this single node of kind that's running. It's going to communicate to the deployment for us. So if we go over to our browser, we can then do localhost 30,000. And we have our application now up and running on a node port. So let's recap. Kubernetes is a bit of a pain to do development with because it's such a big application. You know, we're bringing up a full cluster system that solves some very complex problems for us, such as scaling. So we're able to install a binary called kind, able to create a full Kubernetes cluster with it. We also are creating a local registry that we can push our images when we're developing to, or images for our custom applications, or say we need a database or whatever. You can do complex things like PVCs or create operators that create databases or whatever. It's a full installation of Kubernetes. You then can spin up, or we have a example application that we packaged up, push that into the local registry. We then we took a piece of a deployment or a YAML file that is our deployment. We use kube control to apply that to the cluster, and we've got an application up and running. We also configured kind to expose certain 30,000 as a port, and then we bound and we created a node port that communicated to our application as bound on 30,000. Again, my project is over at GitHub. You can get there via bit.ly/kind-talk. Appreciate your time. Hope you can use kind to make your Kubernetes development more efficient.
Hi, welcome to our session on why nobody buys your product because it runs on Kubernetes. My name is Erickson. I am an independent consultant who is very focused on internal developer platforms. And today we're going to talk about how using internal developer platforms to get your project started quickly and eliminate infrastructure will help you sleep better at night. This is about empowering your engineers to do the best work of their careers. So a lot of us have been in this situation where we have an idea on Sunday night and we just can't sleep very well at all. We're just thinking about it all night. So we want to get ready first thing Monday morning and start working on the idea. We're really, really excited about what we can make. And then we get to work Monday morning, and instead of writing code about that algorithm or that new way that we're going to use machine learning to do something amazing, we're going to, oh man, we got to set up a bunch of things. We need to set up Visual Studio Code, and what about my Docker container? Oh, I got the service mesh thing, and oh, the password needs to go in a vault. There's all these things we need to do to set up just to get to the first line of code that is about your product, not about infrastructure. And in a lot of organizations, this becomes just almost impossible to get past, and you lose your momentum. Oh, now we got to work on the afternoon. We're still not done. We still can't write any product code yet. We have a back-end database to worry about. We have to pick a front-end framework. We have to kind of figure out, are we going to use some kind of gRPC library? How do we get Kafka figured out? I want to use some language that maybe is standard or maybe a little bit less standard. all these different things. Maybe I need observability capabilities to, from the beginning, but we're still not done even with just the setup. And what we find is we've spent an entire day just looking at technologies. It feels very Sisyphean. It feels very much like you're pushing a boulder up a hill, and it really just kind of impacts your productivity. You lose momentum. And what happens in a lot of cases, unless you're really, really dedicated, the idea dies. You just don't have the momentum to get it through. Maybe you don't have the time. Maybe you have other work responsibilities. And so your idea doesn't see the light of day. And that's tragic. That is absolutely tragic. I lament how many ideas die because it was just too daunting to get started. And sometimes it may be a day. I've seen organizations where it can take 6 weeks just to get a developer environment and infrastructure. So one of the things that's happening in the industry broadly is organizations are building internal developer platforms. What's an internal developer platform? Well, here's the idea of what you would do with it. Step one, you pick a type of service that you want to develop. It could be, what language is it going to be? What cloud provider are you going to use? So forth. You then click a button, and then things happen on the back end, and then you start writing code. That is, that helps solve the customer problem. You don't have to fiddle with a bunch of infrastructure. It's amazing. One of the ways I like to frame this is there's all this technology out there. But let's really kind of answer the question. How many really important decisions are you making when you're setting up this stuff? And granted, there are a few. You probably need to figure out what language you are. You probably need to have an opinion about your continuous delivery system. You do need to think about what cloud provider you're going to run on and so forth. But imagine for most services that you run that there are a good set of baseline decisions that work for almost all of these tools. And in most organizations, that actually exists. In fact, in a lot of organizations, there are standards for which of these things you're going to do. There's a lot of organizations where, no, we're running this on AWS. That's who we have a relationship with. That decision's been made for you. Having to use HashiCorp Vault is a decision many organizations it's baked in. You can't use something else. So we can automate a lot of these things, or at least take out the kind of cognitive load of having to make all these decisions. So really what happens if you have a good baseline, there's actually not many at all. There can be 0 important decisions that you're actually making at the time that you're building that. So then why are you having to onboard onto all this stuff individually if that is in fact true? So what I like to think about is creating a golden path, creating a very easy way for you to get on board and get started working on your product. You might want to go off and do something a little bit different, but for the most part, if you stay on this path of whatever the internal developer platform has and the set of decisions that you standardize on, you can be up and running and productive in minutes or hours in the worst case. What I'm really here to do, and this is kind of something I'm really passionate about at an industry level, is automating all the cruft. I just want to program. I just want to write code. I want to build my product. That is what I want to do. So, yes, my new band name, Smart Defaults and the Golden Path. What I think works really well is when you can pick a series of good defaults that work for most things based on your stack, your requirements, some small set of default sets, and then have most of your projects created using those defaults. Simple. So what happens when you're not using those defaults? What happens when everybody kind of does this on their own? Well, this is somebody made a graphical representation of what many microservice architectures look like. I think this is one of the big tech companies where all the dots might be services and all the lines are connections between all the services. Imagine a world where you have thousands of services and each configuration of each service is slightly different. Now, maybe that's needed, but it usually isn't. What you really end up with when you do this by mistake is you end up with what I like to call snowflakes. Snowflake services, congratulations. So I think most of us that have been around the DevOps world for some years and think about how to do infrastructure in a modern way, we know what Snowflake servers are. But have you heard of Snowflake services? Well, they're these every service with a slightly different configuration. We have an entire industry around things like observability and stuff where a lot of the time is spent figuring out what these minor differences are and remediating things around them. But when you put one of these kinds of systems together, it's funny when you talk to a mechanical engineer that looks at a kind of microservice architecture as it tends to exist in the industry. They are terrified. They have a name for this, and we call it the microservice-based self-operating napkin. Or another, so as you can see in the picture, there's way too many moving parts, a lot of just kind of cruft to make the thing work. We also call this in mechanical engineering a Rube Goldberg design because of the amount of extra moving parts, which create every single one of those connections is a place where you can have errors. It's a place where you can have something break. There will be, in this industry, work pretty much forever. Fixing broken microservice architectures due to the tyranny of accidental differences is going to be a growth industry for the next 20 years. I guarantee it. So how do internal developer platforms help? Well, one of the things that I like to think they do is it reduces what I call accidental configuration drift. Generally speaking, if you have 1,000 services in your estate of services in a digital organization, you're going to have, if you have 5 container configurations, maybe one for front end, maybe one for kind of RESTful services, maybe one special kind for machine learning that runs on GPUs, so forth. But if you can reduce that, if you can get that to some small number, it might be 5, maybe 10, that's going to be more maintainable than 500 or 1,000, where every single service is going to run slightly differently. One of the other things we like to be able to do when we're setting these up is to make a lot of the interactions between services work in a more predictable manner using things like common libraries. So for example, you might decide you want to talk to, say you're using Kafka, you want to talk to Kafka in a very similar way across your entire suite of maybe Java services that you're running or whatever language they happen to be in. If everybody's kind of doing their own way they connect to those kind of common elements, that again creates an opportunity for new kinds of issues to emerge in a system, or when there's a cross-cutting concern that has to be fixed, now you have to fix it in every single slightly different library. The other thing this really kind of helps with, if you can standardize on these things, is onboarding time. So, what you want in terms of differences from one code base to the next are not infrastructure differences unless you really need them. It should be differences in what the product does. Most of the infrastructure differences, with some exceptions, there are some good reasons, but they're a lot fewer than most people think, having to do with infrastructure. Most of the differences should be based on the product, what it does, what value it adds for a customer. It doesn't mean you can't screw up even using one of these things. And some of the things I've seen in the industry that you still have to watch out for, these things still cause some issues, are not doing good microservice architecture. Things like using a central database as an integration point. None of this will fix that as a problem. Say for example, you have Kafka format, Kafka message formats that differ in ways that are not predictable, and that you have a downstream consumer that breaks. There's still ways you can break things. There is this implicit coupling or accidental coupling between what kind of look like on the surface unrelated services. There's also just kind of dumb integration. So a naive microservice implementation might have 4, 5, 6 hops between the front end and the back end. And if every one of those hops is a REST call with bad latency, I've seen cases where somebody was developing locally, but then they go to production and suddenly just loading up the page takes 30 minutes because they didn't really kind of think through how these interfaces work. So, that's just kind of an obvious example, but there's a lot of dumb integration cases when in some of these systems. The other thing is what I call the cost spiral problem, which is a lot of times people will not understand the cost implications of choices they are making. So, you just kind of bring services in, you migrate, you do a lift and shift, and then you run everything on expensive instances. Maybe you're not using auto-scaling well, maybe you're not using spot instances on AWS where you can, and so forth, which can have the bad effect of your system becoming basically a good way for Amazon to make money and not you. What you want is for the ability to, for all the services in your organization and for the standard way that they're configured to be something that you can plan for in the creation of it, so that if you want to then later on maybe change how they run to cost optimize, it gives you a leverage point to do that. The other thing I have observed in years doing this stuff is studies show that being tired is the same as being drunk. And so I always like to ask the question, do you like having drunk engineers on call? Is that great? Having systems that break all the time tend to leave you with that. There is sometimes a lot of industry advice that talks about service ownership as always inherently good. And I actually think as a concept, it's great. But I think there's some things where we've taken some basic practices, but then kind of abused and taken them a little bit too far. One of them, I like to think, I call it the anti-pattern of heroic service ownership, which means it is seen as a good thing. You're a hero in the organization. If you wake up at 3 a.m., PagerDuty calls you, and you have to fix the system. Having that as a condition means there is a bug in your system and you need to fix that like right away. Internal developer platforms can help you create a world where that's not the thing, but that's definitely a problem. Which is a version of another problem I've seen, which is when you have SRE embedded in teams. Well, wait a second. Why aren't we just designing reliable systems in the first place? If we have to actually have as a function somebody that's going to be on call all the time and always having to be the person that knows how to fix a thing, that's usually an outcome that is the result of a bunch of bad decisions that have happened in the past. And so what you really need to do is fix the reliability of the car in this analogy, not try to design a reliability around the car. And then, when you think about how internal developer platforms can help, much of the reliability problems go away when there are just fewer accidental differences in how standard services run on standard infrastructure. I actually have strong conviction that if you get the number of ways that services run down to a much smaller number and standardize on that, standardize on some libraries, you can actually resolve a lot of what often are the kinds of incidents that happen in big, complex architectures. Yes, of course, there are always exceptions. If you have lots of implicit coupling, or if you just are bad at writing code and have systems that break because you don't have sufficient testing in your pipeline, this doesn't solve that. Engineering still matters, but at least in terms of how things run on infrastructure, using a system like this eliminates a vast percentage of the kinds of problems that you're going to have. So I actually believe that using a platform like this, using an internal developer platform, will drive better reliability outcomes in addition to solving for some cost, in addition to helping you get products out the door faster. So how do we get this reliability by internal platform? Well, we do things like network configuration by default has redundancy built in. We do things like having standard Kafka libraries that are able to handle intermittent outages in those kinds of systems. And I've seen these kinds of things work really well. You might have just standard logging and observability that, when you create this the right way, creates your alerts in the right manner, gets everything going to the right central place in a kind of consistent way. So you have to set it up a whole bunch of times independently. And then, you can say, okay, well, whenever I deploy, every single thing is set up to be running in multiple availability zones, regions, so forth. You can standardize on that and have the internal platform enforce those kinds of constraints. And then really this kind of applies to any other kind of cross-cutting reliability concern. There's all sorts of other things you can do, like with service mesh and so forth, that can either add redundancy or add better failure modes to systems that will really kind of help achieve the reliability that we're talking about. So how do you make this happen? Well, I saw this problem a number of years ago when I was at Salesforce, and we were having some struggles with this, and me and a group of people decided we'd fix it. And so we did. We built our own internal developer platform, and there was lots of overcoming. But people want to use something different. What does this do for autonomy? Engineers want access directly to AWS console. So obviously a concern and something we had to be able to answer. Lots of worrying about, for good reasons, what I like to call opaque abstractions, where if you need to do something special in one part of the pipeline, you don't want the platform to stop you from doing that. You need an ability to what I call off-road or do something slightly different when you need to go off the golden path. Now, the funny thing is, though, I noticed as people started using the system that we built, that there were actually, most people didn't. Most people found that they could work within the standard constraints, and they had a strong motivation to not do it, because anything you built, any kind of off-roading you would end up having to support. It was usually easier to kind of just not do that stuff if you didn't want to or didn't really need it. And then, of course, especially given where we were, there's always people that, hey, why can't I just use Heroku? One of these exists. And I think if Heroku works for you, you should use it. Or if any other platform that's a little more standard like that works, you should use it. But a lot of organizations have some workflows that aren't handled in that use case. One example is every time we did a new deployment, we need to have a security review. It was a legal constraint. Which to build that into the platform isn't a standard workflow in a tool like that. So things like that, or you might have more complex infrastructure requirements than can be handled in that standard way. So that's a lot of the reasons why people will roll their own if there isn't like a standard way they can do it. And of course, there's still some problems being solved in this industry. One of the things I think we had was there were a bunch of existing services. We want to migrate them in. That's a little bit of a harder problem, because there might be some other kinds of dependencies. You might not be able to necessarily have it run in the standard model. It may have different dependencies on the way mesh works or the way secrets work. So there's kind of a lot of manual work to do a migration. None of that's automated yet, but you can still migrate. It's going to be some work. There are new products that are coming out in this space that I love that it's happening. I mean, this wasn't really considered a product category until maybe even in the last 12 months, but GitHub Actions is one feature within GitHub that you can use to do this. I remember when I first saw Backstage.io, the product, I talked to my team, I said, wow, somebody has an open source project doing a lot of what we were doing in Salesforce. And then the last one, and it's one that I'm really excited about, is there's a new startup in Germany called Humanitech, and they are building internal developer platform products. They didn't pay me to say that. I'm just really impressed by what I've seen, and really am excited that this is actually happening. So some takeaways, some things to remember. No customer ever bought your product because you run on Kubernetes really well. No customer cares about Kubernetes unless they are buying Kubernetes. So, writing all that extra code is not stuff that doesn't create customer value. You may have to do it. There may be a thing you have to do, but it shouldn't be your primary focus. Another way I like to think about this is every task that gets in the way of starting building something, being able to get to production with your first idea, everything gets in the way of that will reduce the number of ideas that move through the organization. It reduces the conversion rate of idea to at least something that can be shown to maybe a product leader that might decide to fund your idea. I want to get more ideas funded, and I don't want to put walls up to that happening. And then, this is a key one, but every slight unintentional difference in how a service runs is a long-term tax on your company that your successors will pay for in sleepless nights. If there's one thing you get out of this, it's tired engineers are as bad as drunk engineers. And we don't want drunk engineers doing work on our system. We want them to sleep it off, come back in the morning, and fix it then. And I think if we can get away from this world where we're constantly on pager duty, constantly just always responding to issues and being reactive, I think the industry in general will be a lot better off. And then getting to that reliability point. Reliability at the platform level is always better than reliability at the service level, every time. and make sure you solve for both. You do not want to be that company that is not able to make progress on its roadmap a few years in because you're constantly responding to issues. That is a tax on productivity in the company, and it is not something that will enable you to compete. Most of this stuff applies for ops teams. Imagine a world where you can use a platform like this to do things like automated patching or other kinds of standard operational tasks that, by the way, get a lot better the more you standardize within your internal platform. Really, really important thing. It's probably its own talk. This is a developer productivity conference. So we're not going to talk about ops productivity, but there is an entire lane of ops productivity as well that applies here. Thank you. I really appreciate everybody watching this. And if you have questions, please reach out to me, aaron.c.erickson@gmail.com, or at my Twitter handle at @AaronErickson. Thank you.
Hello, everyone. Thank you for joining this session where we discussed about how we can leverage the TP-Dataflow to implement robust and high-performing code in a logical way. I'm very excited to present this session. My experience, I become familiar with this tool because the TP-Dataflow at that time was the answer, the right tool when I had to design high-performance in parallel system without compromising the high-performance, coderability, and the robustness of the program. But even better, I was pleased to find out that the TP-Dataflow promotes the pipeline programming model, which can be used to solve complex problems in a seamless and logical way. In a modern application, there are many scenarios where the Dataflow processing is used, such as large volume data streaming, image or video processing, conversion, data migration, and so on. And the TP-Dataflow can be leveraged in all those scenarios. How can we use the TP-Dataflow to solve complicated problems in a logical way? Well, all that you have to do is to break apart a big problem into a small problem. So you have a complex problem you want to solve. And imagine you want to solve the problem in a top-down way. So you start with a big problem, and then you decompose it into smaller problems until eventually are small enough that you can just directly solve the problem. And then, as a result, you have a set of small solutions, which then you can be glued back together to solve the original large problem. And this all leveraging the compositionality aspect of the TP-Dataflow that it offers. And the Dataflow composition is really the glue to put together our big solution. Any world is composed of many autonomous things, and in my opinion, really the TP-Dataflow structure the code closer to those real problem domain, so it becomes easy to reason about your problem, and it provides the tools to build and fine-tune system capable also to process a huge data set and do it efficiently, so you get the best of both worlds. So the main takeaway on this session are that the TP-Dataflow provide a foundation for a message passing programming model that is to parallelize the parallelization for both CPU intense and IO intense application that have a high throughput and low latency. And then the TP-Dataflow gives you explicit control over how data is buffered and moves around to the system, improving responsiveness and throughput by managing efficiently the underlying threads, which allow easily to create a mesh operation that work together in coordination. And ultimately, the TP-Dataflow is a tool to use when performance is critical, when performance is a critical component of your application. So first of all, what is a Dataflow? Right? Is a programming paradigm that model a set operation as a graph, where the data flow between those operations, those steps. Most applications are defined as a series of functions that operate on common data, on common state. And so the data flow emphasizes the movement of those data and define the inputs and the outputs of those connected operations that really look like and behave like a pipeline. At its core, the TPL data flow is a set of constructs built on top of the Microsoft Task Parallel library, which it can help you to create a robust, declarative concurrent program, reducing a lot the complexity that can be introduced in a multi-threaded environment. In general, the TPL data flow consists of one or more blocks, and each block can be connected to another block to shape a pipeline where the data move from one block to another block, and this block are responsible to apply some behavior that you inject on a data that could then be generated and transformed during the pipeline. And the TPL data flow reduces the complexity when implementing concurrent program because it allows us to control the shared state and make it very difficult to change the state and between threads. So the data flow programming model is related to the concept of message passing, where independent component, independent unit of a program communicate with one another by sending messages that are passed as the input value to the blocks. So this programming model is also known as the share nothing, because the blocks communicate using messages rather than shared state, which take back the comment about they make it very difficult to share the state among threads and so reduce the complexity in a multi-thread environment. And when we share this thread in a multi-thread program, traditionally we must use locks to synchronize the access of the shared resources. But lock-based programs do not compose. We cannot take two atomic operations and create one more atomic operation after them, right? So the foundation of the TPL data flow is using building block, and we will see shortly how those blocks look and work. And these components are useful when we want a multiple operation that must communicate with one another, both asynchronously and asynchronously, when you want to process data as soon as it becomes available. In fact, one very important concept around the TPL data flow is that is a push model rather than pulling model, which also emphasizes the reactive aspect of this tool, this programming model. So there are about 14 different building blocks to implement any sort of complex scenario. And in advanced cases, you can even implement your own. For coming demo, we'll use just a couple, but I really hope that by the end of the session, I'll give you the wonder to check all the powerful TPL blocks you could use to implement and solve your problems. So the first block is the buffer block. Is the most fundamental block and represent a general purpose asynchronous message structure that it provides either bounded and unbounded buffer for storing messages. And in general, it's good practice to have buffer blocks at the start and the end of each sub workflow. Some block also have a built-in already the buffer block. Either you have to add yourself, depending on what you try to achieve. But when the target block receives a message from a buffer block, the message then is moved from the queue of the buffer block. And the buffer block is useful when you want to pass multiple messages to another component, and that component must receive each message in keeping the order or the original order. And of course, this component, this block, like all the other block, intrinsically already support both synchronous and asynchronous operation without any changes. But the important part of the buffer block is that it stores the messages in a queue, in a first in, first out manner, fashion that can be written by multiple sources and read also by multiple targets at the same time. And this behavior makes this block a great tool to implement easily sophisticated and high-performance producer-consumer pattern. As you know, the producer-consumer pattern really is one of the most popular and fundamental patterns employed in many parallel applications, with the producer-consumer, where one or more producer threads generate data that is consumed by one or more consumer in a different thread. And this consumer then can themselves also produce or manipulate and generate further data, which is then consumed again by other consumers and so forth. And this really forms like a pipeline, where each level of consumer represent another stage in a pipeline. So another building block is the action block on the TP Dataflow, and it's used to execute a given callback, like for any message, any item sent into it. And you can think this block logically as a buffer for data they combine with a task for processing the input values. So in other words, the action block is a target block, so you can send messages, and then when you receive a message, react and call an internal delegate that you inject when you receive the data. And similar like a for each loop, when the execution of the delegate is done asynchronously, and it will be the default process for all of the elements that you pass into it. Then we have the transform block, which act like a mapping function, which applies a projection function to an input value and provide correlated transform output. So the transformation function is passing argon type of T and producing an output type of R, right? And the default behavior is to process one message at a time, maintaining the strict, first in, first out of ordering as the other blocks. So you can see we have different kind of input here. They transform them to a different output. In the slide, you can see the code, how these blocks also look. And when you send a message post, you send a message. In this case, on the slide, we post a message, which is a blocking operation. But to increase throughput, there is another API that is called send async. You send a message in a fire forget fashion, asynchronously, no blocking, which increases also the throughput of your application. A transform block is generally used in combination with other block, where it passes the output of the projection as input to the next block. In this case, we are linking the transform block to another action block to generate the operation as a side effect. So in general, the action block doesn't produce an output. It just creates the final operation. So in this case, we can, for example, use the action block to, we can use the transform block to transform the data, and ultimately the action block to provide side effects such as maybe persist to the file system, call or persist to the database, and so forth. And also we can link a block to other block at the same time, so we can send a message to different block as we compose our mesh of different kind of building block for implementing our solution. This is our look, and the link function here is actually an extension method that link a source block to a target block, really connected to block. It also provides also some other extensibility, such as you can ingest also predicate a filter, which can filter only the messages that pass successfully the predicate to inject. So you can just send a message to a block, the link to, and send a message to the following block only if the messages, the output satisfy the predicate. The broadcast block is useful when you must pass a message to other component at the same time. So when you already broadcast on the message to different component at the same time, and the broadcast take as argument delegate, they go T to T. There is not really transformation in this block, but allow that to define and override how we want to clone the message, right? Because we want to pass a new copy of the message to the other component that we're broadcasting the message. And this is what the broadcast does, right? And really its uniqueness is that it sends a message to all the link consumer with one post, one send a message. Next, one implementation property is that by default, all the TPL Dataflow block process one message at a time, queuing all the messages and process it, one at a time. However, there are cases when we want to process messages as fast as possible, and it is okay when multiple messages can be processed in parallel. And for this, we can just set the property max degree of parallelism, and which also apply individually for each block. So each block can have its own different kind of level of parallelism. In this case, so each block, we can send multiple messages at a time, and that's going to be processed in concurrently on parallel for both either CPU or IO bound operation. So we can send, for example, when you set the max degree of parallelism 2, we can send 2 messages at a time, and this is going to be processed in parallel. As you can see, the code changes are minimal, and the DOP or degree of parallelism is used to really increase the throttling property for each block. All right, so but enough talking, right, about high-level idea, but let's see in action how we can solve a problem. For this example, I thought to how we can implement parallel web crawler. So the idea is that we know initially what kind of problem we want to solve, and then we break it apart a small solution, and then we glue them together. So for the web crawler here, well, first of all, we want to solve it in step and try to create a smaller solution that we're going to glue them back together. In this case, we generate a downloader, which is responsible to download HTML content from a web page. Then we want to have 2 blocks. One, they link the images from the content of the web page, all the reference images, so we can download the images. And then we add another link parser that parse and extract all the reference to other web pages from the HTML content we just downloaded, which ultimately we can resend back to the original block, the download web page. So recursively and continually, we're going to crawling all the content of the web page. Of course, we have a broadcast in this case to split. So the same content web page is going to send to both the messages of the link parser, link image. Then we have another block to persist the images to the local file system. So receive the image of the reference or the link of the image, download the image, and persist it to the local file system. Just for their purpose, it can be anything else, right? Really. And then ultimately, as I said, we can resend back all the link to the other web pages to the original point where you can start to download all the other pages. And of course, we can imagine all these small steps as a TPL data flow. Okay, so let's demo. And by the way, the source code is on this link on my GitHub, so you can download the code here. We're also going to be the slide to check the code. So I have this solution here. I have the Dataflow web crawler. So As I mentioned, we have different kind of block here. We have the start function that take a list of URL that we want to start to parse at the degree of parallelism, and a callback that is done when we download ultimately the format of the image. We set the degree of parallelism with the value that we pass in the function. In this case, I think it's going to be set to 2. We can be anything. So the first block, he download the image, download the web page and as a text as a content. Then the downloader with the block transform block take the function we just defined downloaded and download the content. And then as the slide where the broadcast, they send the message, the content clone to both the link parser, which you use internally, take the content of the web page, extract all the link of the other web pages in the page, and form a collection that is going to be pushed to the original block. This is the output, which is the list of link other web pages. Same thing for the image parser, which take the link for all the images that are in the web page content. We use the HTML document here to parse the content of the page. So then we're gonna build the block, the broadcast, the message, the output to 2 blocks. Actually, here I have an action block just to do some logging, so we're gonna see where we run the application. And then the other block is the action block, where we download the image here, and then with the byte array, we're gonna call the callback. The callback is defined in what we call the function. We actually set the parallelism to 4. This is the list of, just for the purpose of the link to the web page we're going to use. And the callback is just going to write to the local file system the image that we downloaded. And that's going to be on the folder here that is empty. Last thing here, the last step is pretty much link all the building block that we just defined our solution. So now I'm going to run the application here, and you can see they're going to start to loop together all the crawling, all the web page. We have some logging here, and you can see here all the images are downloaded in our own local file system. All right, and here the logging about the page that we just downloaded and crawl. Well, that's it for this session. I really hope you have you enjoyed, and if you have any questions, please feel free to contact me on my Twitter or email. Thank you very much.